All right. So welcome to the Mixtape Sessions Causal Inference 2 with Scott Cunningham. I am your host, Scott Cunningham, or whatever. That came out weird. But uh want to welcome everybody to be here. I'm super excited about this workshop. There's some tweaks to it that I haven't done before, and I'm hoping to make it even tighter than stuff before. So if you haven't yet logged on to the Discord channel, I know that anybody that has not logged on to the Discord channel, they've probably optimally sorted and they're saying, I don't want to be on there, but highly encourage that you get on there so that you can be a part of the community, and the conversations get stored. So that's the main value, is that there's a permanent recording. You can network, you can get the Zoom links. Do I have the Zoom link? Yeah, I got the Zoom link on there, and all that. You can network with each other, and it's actually less disruptive a lot too with the chats. It says the invitation has expired. All right, hold on. It says that sometimes to people. I don't understand. Here, let me try again. Try that. That work? Hopefully that works. If it doesn't work, then I am at a loss. But hopefully that worked. That work, Eduardo? Okay. So, all right, so let's go ahead and get started. And I'll kind of lay out the stuff here. Oh, hold on one second. I got an email from someone saying that. So Discord, okay. Then did get the discount? No, okay, I got one more person wanting to get the discount. So I got to kind of like somehow keep an eye on this. All right, I got somebody coming in. And all right. Maybe I can put it over there. And then just stay in the Discord. I don't know. Hold on. Yeah, I'll do it like that. Maybe I'll do like this. Yeah, all right, I'll do it like that. So let's go ahead and get started. So it does not work. Does not work for me, sorry. Huh. What happens, Eduardo, when you try to click on it? It says it's expired. It's working for Zahid. Do you have Discord installed? You have it downloaded? You may need to download first. Invalid invitation. Why is it working for some people and not others? Maybe some of y'all could help him in the Zoom chat if y'all think y'all have an idea while we get started. So here we go. We are going to be here. Let's go ahead and real quick kind of set up shop a little bit. I want you to type in Mixtape Sessions GitHub. Okay, and then scroll down. This is like a home for all the repositories for Mixtape Sessions. So we've got, all of them up here except for one on doing applied research. Well, we do have it, but it looks like there's a lot of stuff that got taken down. So anyway, causal inference 2, and if you want to clone this thing, you can clone it. Pull that in, go into your terminal. You could clone it. You can ask ChatGPT how to clone something. It'll download to your local machine, and you'll have all this stuff. We're going to be in the slides here. Oh, let me figure out where I got to put the slides though. I think I have not moved it over. So let me do that real quick. Yeah, I was doing it this morning. So let me do this real quick. All right? And then you're going to need to pull again in one moment, get add, get commit dash M updated stuff. You can tell that I do not have the best etiquette for doing this, but now look, it is updated stuff. So you can pull this. This is what we're going to be doing today. This is what we're going to be doing. So, and in the Discord, we've got a lot of activity. We've got people in the general, but let's do our discussion today inside of the day one stuff. And then I'd like you to introduce yourself to other people. You never know. If there's anything on a side deal you want to talk, you also have these voice channels. I have no idea how to use those. But if you wanted to, you could, maybe write a paper with someone. Who knows how this stuff works? All right. So let's go ahead and get started. That ain't it. All right. We're going to load this up. Causal inference 2, slides, basics. All right. So let's go ahead and get started. So we'll start off here. I think probably until our lunchtime, we're going to do this like kind of light introduction to diff and diff. Okay, so we'll tell you where it comes from. And then we'll move into the actual concrete material after our first break. So first, I'm just going to start off. I'm going to manage your expectations. I'm going to tell you who I am and tell you what this workshop's about. And then I'm going to do like a little bit of some history with it. So thank you for coming. This is Causal Inference 2. I think this might be the 6th or 7th time we've done it on mixtape sessions, but I've probably done this workshop or taught it in some form or another probably a dozen times. I mean, I'm assuming it's got to be at that level or maybe even higher. I don't know. That's me guessing downward over the last several years. I'm the Ben H. Williams Professor of Economics at Baylor in Texas, the United States of America. And the person who runs the mixtape sessions with me is Kyle Butts, who just is finishing up his PhD at the University of Colorado Boulder and has taken a position at the University of Arkansas as a tenure track assistant professor in the United States of America. So shout out to Kyle for getting a job. Here's how it's going to work. We're going to go 9 to 5, 15-minute breaks every hour, 1 hour lunch at 12 o'clock Central Standard Time. It is currently 9:08. We're going to take our first 15-minute break at 10 a.m. Okay? Because this first part's pretty light. The way that we're going to do this is going to be lecture, discussion. You should ask questions all the time, as much as you want to. Exercises, and for those that are on Zoom and oh good, so we got some people here. For those on Zoom, you can log into Discord. That's actually what Pedro just said. You can log into Discord using that link, and then you can get on. So if you haven't gotten on, I highly encourage you to get on. And we just had somebody again. So if anybody, Pedro, or for anybody, if you see somebody come on, just sort of help kind of, if they want to get over to the Discord. As I said, the Discord is actually superior for its, regularly people say it is superior to the Zoom, the Zoom experience, because the chatting on Zoom has a tendency to feel to the guest as though they're interrupting, even though they're not. And it has a tendency to not facilitate the back and forth because you can't, it doesn't have the same feel of it. I don't really know why. And the biggest one is that we get to keep all of the discussion, all of the conversations organized really well. If we do it over in Discord, it carries over. All right. So we're going to do lecture, discussion, exercise, some live coding together, exercises. We got some new exercises that we're going to be doing. What my pedagogy is like, high energy. I think that's fair. Eclectic approach to teaching. It's my eclectic approach is a bit of a desire to kind of emotionally connect with each of you the best I can, even though it's over Zoom, to kind of have a connection, and for you to sort of feel as though you're participating in all of this. At times I might call on you. I'll just click on this button participants, and then I might just call on a random person. All right. The other way that I teach is I move between the econometrics. I go slow. I go slow. Some people find that helpful. Some people don't. The people that come to mixtape sessions come from a very broad background. And so because they come from a very broad background, I try to teach to the median student, the median guest, okay? And or even further back. So I move between the econometrics, I move between the history of thought. I sometimes show videos, try not to overdo it. I'll show applications, I show code. When I say applications, I mean I'll teach papers, I'll look at code. We kind of break code down and really understand the syntax. We'll go through simple spreadsheets. Today we'll do some spreadsheet stuff. My goal really is always exercises. I really want you to just kind of feel like you sort of get this and it's not so mysterious. All right. And so that's part of it. The workshop is intended to take someone who doesn't know anything about difference and differences, and then take them as close to the cutting edge as kind of is reasonable over a 4-day period. The speed with which difference and differences has evolved, though, means that the cutting edge is kind of even now a little bit further out. So a lot of what we're going to do is take us up through covariates, differential timing, which I think that still is the thing that people want to hear about, and then continuous treatments. That's the newest addition that I'm going to be doing, is continuous treatments. So ask questions at any point. I will do my best to answer them. Anything I can't answer, I'm going to try to get the answer by talking to someone who knows the answer. All right. So I have these 3 class goals. My pedagogical goal is to break down the procedures that we talk about into what I call plain English. I know some of you, English is not your primary language, but what I mean is I take the technical material and I teach the technical material and I explain it in plain words using everything at my disposal, rebuilding it into something that you can use and that you want to use. But I also have these sort of 3 goals kind of supporting that, which I call confidence, comprehension, and competency. Confidence is a feeling. That's how I think of confidence. Self-confidence. It's a feeling. You're not trapped by your demons. You're not hearing all this negative self-talk, saying things like you're not good enough or you're not smart enough or you don't belong. I'm wanting that to go away, and that goes away. This says in synthetic control. We're not doing synthetic control, but that I want you to feel like you have a good enough understanding on diff and diff, both in its basics and some of its more contemporary issues, that there's something about the way that it's taught and the way that we interact with each other and how friendly we are on the Discord and how friendly we are in the chat. And we take the position, all of us on the chats, to help one another. Anybody that doesn't know the answer, ask it. And anyone who wants to take a stab at the answer, they should feel free. They should feel confident to take a stab at the answer, and I want it to be a safe place. I want it to be that the Discord and the workshop and the chat is a safe place where a person who feels like they don't belong in fact does belong. That's what I want people to feel confident, like that this is where they're supposed to be. Um, and I know from experience how that you can in a class not feel like you belong. I was lots of time that student, and still feel like that. I still struggle with imposter syndrome all the time. So number two is comprehension. You've learned a lot conceptually. You'll have learned a lot over this 4-day thing, especially if you go back over the recordings, especially if you go back over the exercises and you break down that code on your own time and you do the homework. All right. You'll have learned a lot. And so that's a goal, is that you learn a lot. I want it to be, confidence without knowing stuff is kind of dangerous. So, I want it to be that you feel loved and known and all this stuff and love yourself and feel comfortable, but I want it to be that the confidence also is rooted in a certain amount of skill, and that's human capital. But there's also another kind of human capital, and I'm just going to call it competency, that you could do this yourself. And how do you do diff and diff? You write code. That's how you do it. You don't use rhetoric. You don't talk about it. You write code down in commonly used programming languages like Stata, R, and Python. But I don't really have Python prepped up, but I can point you in the right direction because a lot of this stuff is now ubiquitous and available in all your popular languages. So I think we can at least know where to look. So this is what day one's going to be about. This is sort of the beginner stuff. Okay. But it's not just the beginner stuff. I call it the basics, but it's not just the beginner. It's also my personal take on this material. All right. It's my personal take on this material. Yeah, you want to keep Stata and Python. Well, Stata, you want to keep this stuff open because lots of the times I go into Stata, then I switch into R. And so I'll show you code. I mean, I'll show you some stuff that's available in Python, like the new stuff, but I haven't prepped it. I don't have the code for it. But I know where the software is. So we're going to learn my personal take on it. In fact, my personal take on difference and differences is that it is not at its root a regression. It is at its root 4 averages and 3 differences, and you're going to learn that. So we're going to start off thinking about potential outcomes. We're going to think about the diff and diff equation, parallel trends, estimating it with OLS. And the reason why we estimate it with OLS is because OLS, under a particular specification, as we'll see, will calculate 4 averages and 3 differences. And then we'll talk about inference. We'll do a bunch of exercises in the best way using spreadsheets. And the reason is because exercises, in my experience, really is the best way for a lot of people to understand potential outcomes. A lot of questions come up when you have to go through a spreadsheet that people don't know they don't know. There's stuff there's stuff there's things that you know that you know. There's things that you know you don't know. There's things you don't know that you know, and then there's things that you don't know that you don't know. Okay. And you have to go through lots of different kinds of pedagogies to really try to bring all that don't know stuff into the know category. And some stuff you just don't know that you don't understand it until you have to actually fill out a spreadsheet. And then you're like, I thought I was paying attention. And then, you were paying attention, but until you have to use those muscles, you don't really get it. So we'll do that. That'll probably take a little bit. And then we'll go through my 5-step evidence of diff and diff, which will include, us walking through the event study, walking through an example. And then we'll look at some of my new work on triple differences as a distinction from falsifications with some simulations. And then we'll have a homework assignment. Day 2, we're going to review the homework assignment. All right. We're going to talk about this is about violations of parallel trends. We're going to look at repeated cross sections, compositional change. We're going to look at covariates. We're going to look at covariates by looking at 4 different models, see how they perform against each other. And then we're going to go through a coding exercise on a classic paper by Bob Lalone and an update to it. And then we're going to do a new hands-on example that I haven't played around with, but that Kyle has developed, Kyle Butts has developed. So we're sort of always kind of tweaking the workshop to kind of make it a little better. And so, that's what, all right, I got somebody that just wants to do something. Okay, hold on one second. Sorry, let's see. Okay. 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 Yeah, that was a good idea to keep this open. All right, now let me get back. Okay. Do another hands-on example. Hoping to do this with Kyle's new covariate diff and diff that he developed, this replication. Then we're going to look at these pathologies next week, pathologies of and solutions to two-way fixed effects with differential timing. We'll talk about traditional panel fixed effects. Okay. We'll look at what it's doing. We'll look at panel fixed effects and strict exogeneity. And looking at, and I've got that in the mixtape. We'll go through an old school example using Ching and Hoekstra's Castle Doctrine paper, where they did two-way fixed effects. And I'll kind of show you a little bit. A lot of what I do, I'm trying to kind of give you a sense, not just of the method, but also some of the rhetoric around the method, the kinds of tables that people traditionally made, the kind of figures that people traditionally made. So we'll look at that. And then we'll also look at, starting with the Bacon decomposition to kind of deal with the reasons why two-way fixed effects under differential timing does have this pathology. And then we'll look at a solution, the aggregating of the group time ATT method by Callaway and Santana. We'll go through some simple illustrations, some simple simulations, and then we'll go through a Shiny app that Kyle has developed again. And then day 4, we'll look at event studies, staggered imputation estimators. We're going to discuss a couple of papers that use all of them, simple simulation, and then end of the day or kind of midday, we'll look at continuous treatment, diff and diff. Okay. Continuous treatment, diff and diff. The code is not yet available. So I am chomping at the bit to get that code. It might be I could bribe somebody to get us some code by next week, but supply curves slope upward for with price, but that doesn't mean that I can get to Brant Callaway's reservation price to finish creating the more robust user-friendly code that he's developed. All right, so I'll be doing everything I can. All right, is there any questions before we move on? Anything that anybody has a question about? I'm just going to poke over here in general. Yeah. All right. So, okay. All right. Let's go ahead and start. So this is Dan McFadden. I don't know if Dr. McFadden is still alive. I think he may have recently passed away. Yep. Recordings will be made available. It takes a long time when you upload it to the cloud. When you zoom to the cloud for like a 9-hour or whatever 6-hour thing, it takes a little bit, and then and then Vimeo takes a little bit. So I try to get this stuff done as soon as possible, but it takes a little bit. And so but I'll be trying to. Oh, he's still alive. Good. How old is he? He like 90 something? 86. I wonder if he's healthy. I have been hearing about some people that are not healthy. I've heard some people I didn't know about. I was surprised that Richard, well, that some people are beginning to get Alzheimer's that I had sort of thought of it would be impossible. It's weird as you grow. Uh, you have all these economists that you've known for your adult life, and you've like interacted with them. I mean, I've never interacted with David McFadden, but like some people I have, and then they like you watch them, it become elderly, and then you watch them pass away. It's a strange feeling because usually I've only well, it's just a being in a professional association is a different, I guess, than just like a the other thing. So that's what I'm shooting for, Pia. That's what I'm shooting for. I'm gonna try to get that done. Yes. So it just depends. It depends how long it takes for it to hit. Um, so this is a phrase by Dan McFadden. He says, and if you're in Discord, please introduce yourself over in the networking. And as I said, please be kind and helpful. See yourself as, encouraging people with their questions. A lot of people come to this with a huge amount of heterogeneity, and it can make them feel intimidated. Please be friendly and help people as much as you can. Even if you feel like it's not the right answer, it's probably helpful just to kind of throw out your idea. So this is what he says. A good way to do econometrics is to look for good natural experiments and use statistical methods that can tidy up the confounding factors that nature has not controlled for us. That kind of view of the natural experiment has probably been really at the center of the diff and diff for a long, long time. Okay. So diff and diff is when a group of units are assigned some treatment and then they're compared to a group of units that weren't. And then they're looked at in two periods, like before it happened and then after it happened. And it's one of the most widely used quasi-experimental methods and definitely in economics, but it's even very popular in industry. What's interesting about it is it predates the randomized experiment by about 80 years and uses basic, but it still uses very basic experimental ideas about treatment and control group. It's just that it does not use randomization in that. It uses a different assumption that, randomization creates an assumption that's credible under randomization that allows you to identify the average treatment effect, but you can still get at things without randomization. And diff is one of those. It has its own assumption though. I mean, it's a hard one. So you can use it with panel data sets. You can use it with repeated cross-section data sets. Okay, hold on. I got a thing here. All right. Hold on 1 second, guys. Give me 1 second. Let's just pause while I. Yeah, sorry about that. We sold out and I needed to expand it. So, okay, I saw a chat. So, no. Somebody says sticking to the general. Yeah, Ronald, I was thinking let's stick to the day one and then our diff settings, sort of a natural experiment. I'm gonna let those questions sit there. You guys ask those questions. Anybody that wants to try to give an answer to it, we'll see as we go along. But diff settings do have a tendency to be used in natural experiment situations. They don't have to be, but you do see them used that way. And I have seen people, Lygia, use it with matching. I'm not going to cover that. The but we'll do something else. Okay. Are we sticking to the general? All right. So, all right. And now what I'm going to do is I'm going to do a quick run through of the history of diff and diff, all right? Social history of diff and diff. All right, so here we go. Where was it started? It was started in, we ask questions next week about it. Yeah, sure, Arthur. We're going to cover it next week, actually. So, that's even, we can definitely, when we cover the Borsak paper, that's a good time to talk about it. That's one of the ones we're going to cover. So here's where diff and diff, the first time it's cited in the wild. All right. So it's Ignaz Semmelweis. Early 1820, he's a doctor. Early 1820s, Vienna passes legislation, says if a pregnant woman gives birth and wants to go to the public hospital, which provides free care, she can. Depends on the day of the week and the time of day. But so they've got like a schedule. It's pretty strict schedule. If your water breaks like on a Tuesday at 4, you got to go one place. But if it was a Tuesday at 3, you got to go to another place. Probably this resulted in random assignment, but there were two types of wings. There was the midwife wing and there was the physician wing. And I don't remember the reasoning of the Vienna legislators. I have a theory of it off the top of my head, but I don't know if that was right. By the 1840s, Ignaz Semmelweis and others have noticed that pregnant women are dying at 4 times, 5 times the rate in the male wing than they are in the female wing. The male wing is the physicians, the female wing is the midwives. And they were dying of something called puerperal childbed fever. It's a primitive time. Most of the theories of diseases were not really well developed. The theory of the germ theory didn't exist. You had things like the miasma theory of disease transmission. You had things like these, I don't even remember all this stuff, like the humors inside the body and all this stuff. So this was a bit of a mystery. But weirdly enough, it was also known. And women in the community, even poor women in the community, knew about this. And so what they would do if they break water and it's Tuesday at 4, they missed their window, they just give birth in the street rather than go to the physician because it appeared to be related to delivery, not being in the hospital. It was all about the delivery that did it. So they'd give birth in the street. There's anecdotes of that, and they would just walk across the street to the hospital with the umbilical cord in their hand and go inside the hospital for the after delivery care. So it was pretty severe. Semmelweis makes a conjecture. He was very astute. If you get his book, he's just one of these physicians. Jon Snow's like that too. He's extremely observant, very, very observant. And he makes a conjecture after a lot of observation that the cause of this is that the teaching faculty, the physicians, who were delivering the teaching faculty were the physicians. They were the physicians that were delivering these babies. And why is that a big deal? Because the physicians, the teaching faculty, were teaching anatomy using cadavers. And they'd be sticking their hands inside dead people, and then they'd go deliver the babies without washing their hands. And so, because they didn't have a theory of germs, so they didn't know they needed to do that. So, Semmelweis, and the midwives are not teaching anatomy. So they're not getting the cadaveric material is what Semmelweis calls it. So Semmelweis thinks the mortality is caused by working with cadavers. He does not have a theory of germs. He just calls it cadaveric material or maybe even cadaveric particles, but he doesn't know why. He doesn't have a theory of bacteria. And so he convinces the hospital to have physicians wash their hands in chlorine, but not the midwives, and it creates a type of diff and diff design. Now you can see here how bad it was. Going back 1841, it was like, this right here is a 16% of those in the physician wings are dying from postpartum infections versus 8. They are kind of moving in similar patterns, which is going to be useful as this later. They're not the same levels, but they're kind of moving in similar patterns. And then he does the intervention, I think, in 1848. And I mean, it's incredible. It just levels, it becomes equal, completely equal. Nobody believed him. The diff and diff evidence was rejected by Semmelweis's superiors. They claimed that it was not caused by the chlorine. It was caused by the hospital's new ventilation system, which would have been throughout the entire hospital, not just the physician wing. So that kind of like shrinking it, I don't think makes as much sense. But the dominant theory of disease was that, odors caused disease. It was called miasma. And so the ventilation system was, the dominant theory. So, his like hand washing theory was kind of ridiculous. He begins to show signs of irritability. I mean, basically what happens is very, very sad. People don't know exactly what happened with Semmelweis, but he did begin to become very combative. He would write articles attacking like, public officials, attacking, chief, heads of the hospital, all this stuff. And he's extremely irritable and begins to kind of have a strained relationship with his wife. She begins to think something isn't normal. People have thought maybe he starts showing signs of dementia because of a lot of his behavior. He gets committed by his best friend to a mental hospital, and within 2 weeks dies from wounds he received while in residence, which is very sad. So despite the strength of evidence, his diff and diff was rejected, which is a theme that we're going to see. Number 2, John Snow. This one most people know, so I'll just kind of go more quickly. 3 waves of cholera in the early mid 1800s in London. Again, the main theory of disease transmission for cholera was that it was being spread by dirty air. And usually this included dirty air that was just kind of sitting in the air. It wasn't person-to-person transmission of like breathing on a person, where you would have water molecule, water molecules or whatever. Even that wouldn't have spread it, but it wasn't anything like that. It would just be like smelly sewage, would do it. So John Snow, though, had really worked on the front line of this for 30 years, all throughout all 3 major waves. And he didn't think that's what it was. He put together a germ theory. This was the germ theory. And both this theory and Ignaz Semmelweis's theory only gets confirmed when Louis Pasteur begins to do his work later. But Snow says, here's what's going on. It's coming through the Thames River water supply. What happens is you're eating food and you're drinking water, all of which is kind of like being, using the water supply that comes from Thames, and you're eating these food and drinking this water. And inside the water and inside the food is an invisible creature. Here's his germ theory. An invisible creature, he's never seen this invisible creature, that enters the body through food and drink, causes the body to expel water because of poison, placing the creature back in the Thames River, killing the host in the process, causing epidemic waves. Because it was so violently because it was so violently ruthless, it killed off all the hosts, so it never would like stick around. And so it was just these big waves, and then it would disappear. So that was the whole thing. It's like when it showed up, it was terrible. So they passed an ordinance, London does, requiring the water utilities to move their pipes upstreams, not because though, so Harsha says, how would you expect the midwife curve change if midwife? Well, midwives were not getting, they did midwife, it should have had no effect on the midwives. Because the midwives did not handle they didn't handle the cadavers. So that was why it functioned as as a comparison group. It's untreated, you know. So it's not a pure diff and diff, but like that we'll talk about that later. So they don't move it because of the cholera. They move it because the water does not taste good. Downstream from the city, it's full of sewage. And even though they have filters and stuff like that, they're not able to like get everything out, and it's just not tasty. And so they want to move the water upstream. And Snow has been working on this theory about the invisible creature for a while. And he sees this opportunity. He sees this opportunity here because between 1849 and 1854, Lambeth moves its pipe. Okay, moves its pipe between 1849 and 1854. Suffolk and Vauxhall does not. This is a map, 1854 map, and this 1854 map has some interesting things. So this right here is the blue. That's the blue right here. This is Suffolk and Vauxhall, meaning Suffolk and Vauxhall basically covers the houses and the businesses that are located in this area. All right, located in this area. Yeah. Okay, so that's where Suffolk and Vauxhall are. And then we have Lambeth, who moved just the pipe, but Suffolk and Vauxhall don't. And Lambeth works this area. And it's like, it's the but what we also have is this purple region. And this purple region is where they both are. It's where they both are. Okay. Now he goes to great lengths to basically say that inside this part it's nearly identical families. Like he kind of makes an argument that it's random, that like nobody's choosing, Suffolk and Vauxhall or Lambeth based on their own characteristics. They're like observationally equivalent. And so like he goes through, he doesn't have tables per se of it, I don't think, but like he's got a lot of writing. And he basically says, they'll be like Lambeth will be on one side of the street, and then their neighbor next door will be Suffolk and Vauxhall, or across the street. It was just like kind of scattered all through. And so what happens is that 1854, okay, both of them have their pipes upstream, and 1849, they both have their pipes downstream. Sorry, they're getting their water from the Thames downstream. This is the Thames River. You can see it. And then Lambeth moves it upstream. Okay. They move it upstream. However, they're like, distributing this water. But, sorry. They don't. I don't really know the story. For some reason, Suffolk and Vauxhall delay. I don't know if they're penalized or something, but they do not have it moved by 1854. Right. So this is an example of what I use lots of times to kind of explain the logic of diff and diff is these simple tables. All right. So you've got here Lambeth, you got here Suffolk and Vauxhall, and the before period would be 1849 and the after period would be 1854. And for Suffolk and Vauxhall, before would be 1849 and after would be 1854. And these phrases before and after, they're really describing Lambeth. You know, they're describing Lambeth. When did Lambeth move its pipe? Not Suffolk and Vauxhall never did. So it doesn't really make sense. Before and after is not describing anything Suffolk and Vauxhall did. It's describing what the treatment group did. Okay. So you've got here, notice these letters Y. All right. These letters Y are measuring average cholera mortality in a given year for a given group. So like, and we're going to call, oftentimes we'll call it the baseline. So at the before period or at the pre-treatment period or the baseline, you could calculate how much cholera mortality happened in the Lambeth areas. You could calculate how much happened after. You could calculate how much happened before. You could calculate how much happened after. You'd end up with 4 averages. Okay? 4 averages. I think it's the union. Guan, is my understanding, but I cannot remember. It's in his monograph, but I think it's the union because he goes to great lengths to really describe the overlap, the areas of the overlap. But I could be mistaken, but I think that's right. Although I'm not positive. Okay. Because I think he likes the overlap because he kind of feels like they're comparable. It's the same area, so it would control for the smells and all that stuff. All right, so look, at the baseline period, average mortality, we're going to just say it's based on L, which just means it is based on, it's equal to cholera mortality in the baseline. We're just going to call the baseline L. And then in the after period, that's when they've moved the pipe. But there's 2 things that always happen in this after period. One is this, that cholera mortality grows from L to, LT. We're just going to call it the LT trend, right? It's just like, it just changes. Nothing ever is the same, over a 5-year period of time with an epidemic. It's not going to be exactly the same. And then there's D. Now, these things happen at the exact same time. So think about it for a moment. 2 things happening at the same time. And as a result, Y is like different from the baseline. And you would go, all right, Y is different from the baseline. Why? Is it because of the trend or is it because of the treatment? And so you can't separate them because they're just like all that post-treatment is just like, baseline plus the trend plus the treatment, right? And then over here with Suffolk and Vauxhall, you have the same kind of logic at baseline. There's just cholera mortality that's unique to Suffolk and Vauxhall. And then over time, over the 5 years period of time, it just changes. It goes from the baseline to some natural trend, some second level, right? All right, so then what do? We go with diff and diff. We do a first difference. We say after minus before. Always it's after minus before. So when we do after minus before, let me just get something here. Okay, watch what happens. Boom, that goes away. After minus before for Suffolk and Vauxhall, boom, it goes away. Okay, so now we end up with after minus before, and I got this LT in red because in the first difference, you do not know how much of that change in Y is due to the treatment effect and how much of it is due to the trend, the unobserved trend, the trend that would have happened. That's the thing. It's the trend that would have happened had, it's that, right? The LT is, well, if he hadn't moved the pipe, then how much would cholera have changed in Lambeth? But he did move the pipe, so we don't know. So the diff and diff is to then take this group This first difference for the quote treatment group, Lambeth, it's a number. All right, it's a single number. It's the delta y. It's equal to some number. And we're going to subtract out that number, that first difference, which is some number. It's not letters, it's numbers. And then we're going to say, all right, well, that number minus that number in our little, kind of thinking through the additive elements of the diff and diff, you end up with the treatment effect plus this Lambeth trend that never happened. Okay, that's a Lambeth trend, meaning had they not moved the pipe, how much of a change in cholera mortality would there have been? Minus Suffolk and Vauxhall's trend. And you can see here that this method is going to give you the truth. It's going to give you the true effect, even without a randomized experiment, if LV equals SV, because if the trend, the unobserved trend, the trend that did not happen, that would have happened had the pipe not been moved, if that is equal to the trend in Suffolk and Vauxhall, then that is equal to 0, and the diff and diff is actually going to isolate something called the treatment effect. Okay, and that's the basic public health origins of this method. But in economics, it's more recent. It's a more recent thing. It gets kind of independently discovered. And usually I go into this exhausting, like long history of this. I'm just going to stick with the big picture. So basically, this is from a paper by Janet Curry and 2 other students, I believe, or co-authors, 2020 in the American Economics Association Papers and Proceedings. And for those of you that are not from economics, okay, I want to not assume anything. These 2 things right here are kind of like special places where papers are published. This is a working paper series by the National Bureau of Economic Research. It's like a members only. You have to be a member of the NBER in order to post your paper to the working paper series. Everybody reads it. Everybody gets it in their mail. And all these papers usually publish very well. And that's our top 5 journals. All right. Our top 5 journals are the American Economic Review, the Journal of Political Economy, Quarterly Journal of Economics, Econometrica, Review of Economic Studies. They're called the top 5. All right. And what they did was they scraped all the top 5s by name and like not just by name, actually, all the papers. It's a huge database of all top 5s and all NBR working papers going back to 1980. And then they calculated what percent of them use the word diff and diff. And you can see there's like a little bit of activity here in the beginning, then it grows. Then there's like a flattening right here, and then it grows, right? And in the top 5, you don't really quite see the flattening, but it also grows, right? So, where did it settle in 2018? In 2018, about 23% of all papers yes, there have been studies on the robustness of how much of large, that I don't teach it, Reese, but I can point you to it. John Roth teaches on it. He's got a paper about it. You have to do a bounding exercise to kind of figure out, how bad can that thing be before I still find an effect. And that's like a bounding exercise. So they'll do that. And so 23%. And then for top 5, 16%, which is kind of interesting because what this is basically saying is that the difference in differences method is viewed by the economics profession as a perfectly credible scientific method that's like, will be taken seriously as sources of evidence. Okay. So it evolved in 3 waves, though, in economics. And I want this to kind of help you understand a little bit about where all this comes from. The first wave, I'm going to say, goes from like here, 80, 81, 82, 83. Look, that's the first time the word appears. Even Ignaz Semmelweis and Jon Snow, they don't call it anything. They just do it and they present it in various ways. So it goes from first, I call it the first wave. This is from my own kind of research. The first wave goes from 83 to 2011. I'll explain why I date it to there. It goes to like about right there. Then there's that surge. From second wave's 2011, 2018, the surge, and then 2018 to the present. That's the third wave, right? And initially, it was used by the labor economists throughout the 80s and 90s. I mean, well, there wasn't a lot of people, but if you were using it, it was by the labor economists, and it was part of this like program evaluation area, but it basically spreads. It spreads to all the microeconomics areas with the spread of causal inference more generally. But initially, in the first wave, it does not use potential outcomes notation. It does not ever mention parallel trends, and it does not cover event studies. Instead, you'll usually only hear about something called Ashenfelter's dip, which was evidence of selection bias. All right, so here's Ashenfelter and Card in their 1983 working paper. And here you can see they say, this difference in differences estimator provides an unbiased estimate of the training effect because, and then they sort of basically make some kind of argument that these two things are going to be equal to that, this sort of beta for the 1 minus p group, or beta for the 1 minus p. Ashenfelter dip closely linked to diff and diff methodology. All right. Signs of selection bias visible in the time series data was something that they would look for. It was when you had these two groups, sudden break from common trends between the two groups, and happened just prior to treatment. Usually it was a sign of economic distress. And Jim Heckman calls all of this kind of like, this sort of discussion of sorting and the sorting showing signs of selection bias, calls it the Ashenfelter dip. Card, in an interview I did with him, he links it. All right, hold on one second. We're going to listen to this over the break. All right, we're going to listen to this over the break. I just need the sound system to work right. And he links it to parallel trends and modern event studies. But those words, parallel trends and event studies, do not appear in the published version, 1985 Restat. Okay, so let's take a break. Let's listen to this. We'll be right back in 15 minutes. Diff thing. You mentioned, I actually didn't know about the California paper, and then the Mariel Boatlift paper I do know about, and then all the work in the about it in the 70s and 80s and things. But I actually kind of had the impression from stuff that you had written with Orly that you were a little lukewarm about the method a little bit, that it wasn't really probably, always something that you would have found very credible. Is that accurate?
Well, because, in the original training program case, you don't have parallel trends.
Yeah.
And so it wasn't something that you could just count on being able to apply out of the box.
Right. So you were, so this idea of parallel trends from the very, very start, you were kind of like, you were thinking about it from the very, very beginning. It wasn't just diff and diff without it. You were, no,
it's right there in that 85 paper, the paper that introduces the term difference of differences. It basically, unfortunately, we didn't have a graph, but if you when I teach the paper, I show the graph, and it's got a very big dip for the treatment group. And that's the thing that everyone nowadays calls the Ashenfelter dip.
Right. Then how come they don't call it the card dip? You feel like
they actually been identified in Orly's earlier paper.
Oh yeah, okay. I was just
and so we kind of knew that you couldn't use a straight up difference of difference system.
Right.
And that's why we kind of invented this selection correction difference. Which no one has followed up. No one likes that. That was kind of a loser.
Well, it's like, I only have a few more minutes. I guess I gotta skip something. I
mean, I can go till 3:30 if you want.
Okay, good. I do actually want to do that. Yeah.
So this design stuff, this model versus design stuff, I can't get, ever since I saw that speech, I feel like
Okay. So I'm gonna give it, we'll get that. That was all I wanted you to see. But we'll pause it and we'll be back in 13 minutes. Okay. All right. Little behind here. But did you notice he said, all right, so Card says, I said I had kind of always heard that you were a little lukewarm about the diff and diff. And because I was talking about that 1985 Review of Economics and Statistics, and he said, well, it didn't satisfy parallel trends. And he starts talking about the Ashenfelter dip, and he says, that we didn't, we didn't show the event study. We didn't show the graph. He called it the graph. We didn't show the graph. So in fact, like the word parallel trends, though, does not appear in the paper. So there's these share, nor does the word event study. So the share of NBR working papers that use diff and diff went from 11 to 12% in 2011. Look at this part right here. So it's like right here, it's 10, it's like a, something like 11, 12% or something. Goes from that to 23%. Took them, so, and then to 23 in 2018, it goes up 11 percentage points, right, over those 7 years. It had taken 24 years to reach 11% the first time. Okay, so like, to go from here to there took 24 years, but to get 11 percentage points, and then that only took 11. So it really starts to take off. Okay. So 2011 marks the start of this second wave. And I have various reasons for why I start that. But it has very clear patterns, including the growing speed of adoption. And wave 2 starts to link for the very first time parallel trends and event studies to diff and diff. And the reason why I kind of mark it that way is because like here's 2011 right here. That's 10, that's 2011. It takes off. And the word event study, they also looked up event study. It also takes off. It also takes off, right? So prior to 2011, authors did not mention parallel trends when they would write papers using diff and diff, even though diff and diff was something like a big chunk of the papers, nor did they use event studies. Event studies were solely, it was a phrase. Event study. It did not mean what we mean by it. Now, there's two groups that use it. There's a group in finance accounting that uses the phrase event study to investigate whether or not there are abnormal, hold on one second. Let me get my preferences back. So I'm going to test the microphone. Okay. Where they test for abnormal stock market returns. That's what the event study was developed for. I mean, I think it's Fama, Eugene Fama. And I think it even goes back before Fama to that guy's name starts with an A, but in the 50s. Okay. But it was not linked. It was not linked to, Waldo, we're going to talk about it. So it was not linked to the diff and diff. The event study is the graph that Card was talking about. It's particular data visualization that is done in the difference in differences that is viewed as being pretty, one of the more convincing pieces of evidence that this thing called parallel trends holds. But starting in 2011, suddenly these diff and diff papers in mass start using the word event study and or parallel trends. And these papers grow exponentially at a rate of 66% a year. So this is exponential growth in both event study and parallel trends. So these are papers that used both of them, parallel trends and event study, at the exact same time. You would only use parallel trends with diff and diff. So this is the log. And you can see here, starting around 2006, it goes up, goes down, but then 2011, look, linear growth in the logs, 2011, skyrockets. 2000, papers by whatever year, 2022, are out that use the word at Google Scholar that use the word event study and parallel trends at the same time. So we're going to break it down a little bit. I've got the use of the word parallel trend with diff and diff, event study with diff and diff, and then something called common trends plus diff and diff, right? So so here we are, 2000, 2002, 2004, 2006, and it starts to take off. Okay, which one? Parallel trends plus diff and diff starts to take off. What else? The event study with diff and diff. They had all been pretty flat. In 2000, the base series is 3, 2, and 4 papers that used all three. And if we go from 2010 to 2022, base values were 52, 41, and 37, and really takes off for parallel trends. Parallel trends really starts being mentioned a lot with diff and diff and event study. And this thing, common trends, kind of doesn't. So originally, parallel trends and common trends were synonym for year fixed effects. That's how they were typically used. Moreover, here's an example. Moreover, given the increasing dispersion of incomes and wages among all groups during that period, the common time effects, common trends, assumption among the unobservable components across the two groups may not be satisfied. Early identification by Richard Blundell, I interviewed him this week, and he's going to be on my podcast on Tuesday. Early identification by Blundell was a form of strict exogeneity that's based on panel data that are used in two-way fixed effects. But this kind of use of two-way fixed effects, which depends upon strict exogeneity, which is represented right here, was viewed as too strong by Susan Athey and Hito Embens in a 2006 Econometrica. They write, note that the full independence assumption, error term independent of time, the post period and the group, it is stronger than is necessary for diff and diff to give the average treatment effect. That in fact, you don't need that kind of whatever is implied by this, which we'll learn more about on the 4th day. Whatever is implied by this strict exogeneity, it is too strong. It'll do it, but it's not needed. So in 97, Heckman, Ickamer, and Todd is a paper we're going to talk about tomorrow. They introduce parallel trends. It's the first time I can find the notation for parallel trends, and it's a conditional parallel trends assumption. It's a 97 article, and they're the ones that do not do what Blundell did. Blundell's was in 2000. Before that, they introduced conditional parallel trends, and they use it for identification in a diff and diff. And here is the assumption, the parallel trends assumption, but they don't call it that. They don't call it that. In 2009, in Mostly Harmless Econometrica, Chapter 5 is entitled Parallel Worlds, Fixed Effects, Difference and Differences in Panel Data. Does not say parallel trends, but does give this picture and shows the counterfactual trend in the before and after, and then says that's the treatment effect. It's all kind of coming together sort of slowly. Well, they're nothing the same, Anna. They're nothing the same. Fixed effects are dummy variables. Fixed effects are dummy variables in panel data that dummies out every panel unit. That is not what parallel trends is about. Parallel trends, we're going to talk more about this on Thursday, next Saturday, but parallel trends, that's what we're going to talk about today. So the third wave has to do with heterogeneous treatment effects and two-way fixed effects, and that's the world we're in right now. And the third wave has basically been characterized by this scrutiny of, we're going to get into it. We're going to get into it, Harsha. The third wave has been characterized by the scrutiny of the two-way fixed effects estimator that starts in 2018. Okay. Economists were using two-way fixed effects. It was a panel estimator. They were using it for diff and diff because you could use panel data to do diff and diffs, and you could use repeated cross sections. And if you look back at Blundell's thing, Blundell is basically talking about a panel assumption called strict exogeneity. So people were using it. There was a lot of subtle assumptions buried in the details of that strict exogeneity that we're going to talk more about. It was not made explicit. Now, this is an event study. For those of you that are asking, here is an event study by David Otter, who's at MIT. And he's studying unjust dismissals. Unjust dismissals. I don't remember what this was about. Some law. He's a labor economist. Some kind of law that allowed you to basically, I guess, if you were dismissed unjustly, something would happen. I don't know. And this is not very helpful right here. But like the event study shows circles and lines across time. And you have this like 2 years prior, 1 year prior, year of adoption, after. And notice how pre the point lines are on the 0 line, and then post they're not. They're above it. These are confidence intervals. These are point estimates from a regression. And then pre-treatment, he's showing that point estimates are 0, right? But notice what he says. He says, in applying the diff framework to the data, it is important to consider carefully the experiment created by these court decisions. In the ideal case, the court decisions would be independent random events that varied in timing and had no spillover effects to non-adopting states. Assuming further that the treatment effect of the common law exceptions was constant, equation 8, if correctly specified, would provide an unbiased estimate of the average treatment effect. That's what he says back in 2003. The third wave of diff and diff was has been all about exploring what if the treatment effects are not constant. Will equation 8, which gave this picture, will that be correct? Will it be unbiased or will it be biased? Paper starts with Kirill Borisak and Xavier Yarvel, 2016 working paper posted to SSRN, later gets published with Yan Space in 2023 or 2024 in Review of Economic Studies. This is the paper that kind of starts a lot of this. They were graduate students at Harvard. And this is when diff and diff gets linked with heterogeneous treatment effects and the pathologies of two-way fixed effects. And that's when we begin to see a shift away from two-way fixed effects. So here's, again, the words diff and diff, but now we have new phrases, diff and diff, and this phrase average treated on the treated. That's the blue line. It's really not mentioned from 1990 until around 2002, and then it begins to rise. Diff and heterogeneous treatment effects, that's the red, nothing. Diff and two-way fixed effects is getting used a lot. Starting in the second wave, which we said was 2022 to about 2011 until about 2017, we see the blue line continues to rise. Now we're watching the words ATT continue to rise. Now we're beginning to see heterogeneous treatment effects go up a little bit, and diff and two-way fixed effects continues to rise. But then they pass. Starting in 2020, two-way fixed effects goes up, and there's a bit, or sorry, two-way fixed effects and diff goes up a lot. Okay. And yeah, they all go a lot, but all of a sudden there's a big increase. Okay. But then if I look at diff and diff over the number of diff and diff papers over the number of papers that say two-way fixed effects. So just says that they say diff and diff, and these just say two-way fixed effects. They had been kind of like growing together. Diff and diff was happening more. And then all of a sudden, it begins to fall. Yeah, I will. I'll explain it. I will explain it. So diff and diff moves in distinct waves. We're going to get into it. We're going to get into it. We're going to get into two-way fixed effects. I was just wanting you to kind of see the big picture that what we're sort of doing in this class. Two-way fixed effects is a particular kind of panel estimator that became the main tool for difference in differences. And in the third wave of diff and diff, it turned out to realize that the model had problems when there was heterogeneous treatment effects. And even the words heterogeneous treatment effects combined with diff and diff, that's a very late addition. Okay. It's a very late addition. So diff and diff has just kind of evolved slowly, piece by piece. And the things that we really associate with it now, they weren't always there. All right. They weren't always there. So this, I hope, can kind of help explain the whole workshop, which is largely going to be following these waves. And we're going to see that once the method of diff and diff wraps around this idea called potential outcomes, the problems with some of these models, but not others, become very clear. So our focus is going to be on the parameter of interest, and which is going to be called the average treated on the treated, which I mentioned right here, average treated on the treated. Okay. That's going to be our focus. It's going to be on that parameter of interest and the minimum assumptions needed to identify it and the estimators at our disposal and what constitutes a convincing case, right? What do we have to assume? What is the parameter? What do we have to assume in order to use data to identify it? What are the estimators we should be using? And what does it mean to present a compelling, convincing case using difference and differences? Probably this holds for any study, but it definitely holds for diff and diff. Okay. I know there's a lot of questions. It's hard to kind of, bring up stuff that you're going to see later, but I wanted to at least kind of give you a big picture view of the last several 30 years or whatever it's been, 40 years. Okay. So I wanted you to kind of see where this method has come from and, how it's evolved and it's become a lot more sophisticated. Whereas in the beginning, it was really a lot simpler. All right. Okay. Diff and diff, we're going to cover potential outcomes. We're going to cover something called identification, estimation, and inference. All right. Identification, estimation, and inference. All right. So let's see what we have here. So traditional econometrics, all right, the way that traditionally econometricians teach or the way that they approach problems, okay, is they have like a three-step procedure. They have like a three-step procedure. Basically, they say, what's your causal parameter? You have to turn your research question into a causal parameter. You then say, well, what are the beliefs that you need to estimate that particular causal parameter with data? We normally think of the causal parameter as this, we'll think of it more like y beta x plus, gamma g plus error, right? So we'll run a regression and we'll be like, that's my causal parameter, right? But we'll always do it. Notice that usually the way people start is they start with a regression, not a causal parameter. They'll run the regression and then they'll kind of just hope that regression is causal, and they'll maybe talk about it as the causal effect. They might say as though there's only one. But usually what people do is they just run regressions. They skip over this kind of first stage of saying, well, what is my parameter? They might talk about beliefs, but usually they're going to stick it in a regression and they're going to say exogeneity. And then they're going to, create a calculator or an estimator that'll use data and estimate that causal parameter under those assumptions, right? And a lot of people just skip to the third step. They'll just kind of say, I'm going to run these regressions. And then they'll state these assumptions, but they will have never sort of begun with a first step of this is my research question. The reason why that matters is because, as we're going to see, there's different causal parameters. Now, here is a two-way fixed effects model. It's a regression model. It's the simplest two-way fixed effects you could do. You're going to observe data over time. Here I have individual level data, I, observed at the state level, and over time. It's going to be panel data because I'm going to observe a person over time. And I'm going to put in a dummy for post-treatment. And I'm going to put in a dummy for whether or not you are in a treatment group. Not going to put in panel fixed effects. I'm going to put in a dummy for whether or not you belong to a group that was treated. Then I'm going to interact it. That's the 2x2. Well, that's the OLS. Sorry, that's the OLS specification for a diff and diff. It might sometimes be called two-way fixed effects because they'll say that's the group fixed effect and that's the time fixed effect. Okay. And then you have to interact it. Two groups, one treated, one not treated, treated group treated at a particular point in time. Okay. Well, this coefficient is numerically identical to 4 averages and 3 differences. All right. 4 averages and 3 differences. I want to show you what I mean here with this stata, stata command here that I have in lab. You can call it basic diff and diff. Equivalence.do. There's an equivalence.r, but I'm going to look at equivalence.do. All right. And I'm going to make a simple 2x2. Okay. I'm going to make a simple 2x2 where I'm going to use this data set called the Causal Doctrine data set, which is a data set where people, a group of states of about 20 states in the United States passed a law that allowed you to use lethal self-defense in places that previously you were not allowed to use it. We're going to drop anybody that gets treated in 05, 07, 08, and 09. This F year is referring to the year they got the law. What we're going to do is we're going to put in a post dummy and a treatment dummy. Okay, so we're going to put a post dummy, treatment dummy in. And post dummy is going to be if it's after they were treated, they're going to be treated in 06. And the treat dummy is going to be equal to 1 if you're one of those states that got treated in 2006, okay? I do it 2 ways. So I'm going to regress log homicide onto post, treat, and the interaction, right? So that's post, treat, interaction. I'm going to run it. And I get a 0.0862359. That would be a 6.8% increase in homicides. It is not statistically significant. Could also do it this way. Post, treat, and I could do the interaction myself with these IDOT terms. Oh, gotta do this. .0862359. 0.0862359. Well, I said that the coefficient on the interaction is numerically identical to 4 averages and 3 subtractions. I could take the average for the treatment group. I'm going to call the treatment group K. I could say I take the average of the treatment group in the post period. I could take the average of the treatment group in the pre-period. I could take the average of the untreated group in the same post period, the average of the pre-treatment group in the pre-period, and I could do 4 averages and 3 subtractions that way. So I'm going to do that. Y1, the log homicide in the post period treat. All right, so that would be this one. Then I'm going to say I'm going to say average of the homicide in the pre, if you're in the treatment group. So that'd be, sorry, that's the post and that's the pre. And then I got to do this little thing right here where because I gotta like fill out a column here of all of those, right? So now I got to do it for this one. I got to go, whoops. post period for the control groups. That's going to be this one. And then I got to do pre-period control group. And then I got to fill out the column. All right. And so now I have 4 averages, 3 subtractions. 1, 2, 3, 4. So now I'm going to do this equation, which I call the diff and diff equation. All right, let me do that first. Let's go back to this regression. When I run the regression, treatment dummy, post dummy, interaction, the delta coefficient on the interaction is a 0.0862359. When I take, and I said, when you calculate 4 averages and 3 subtractions, which I did here, look what you get. 0.0862359. Exact same number. They are numerically equivalent. Listen to Orley Ashenfelter talk about this. Hold on, let me get this again straight. And you'll see why he decided to call it diff and diff. All right.
I was read out very long. Yeah. And there's the differences came about in a very simple way. Here I am running regressions with hundreds of thousands of observations, fixed effects for individuals, fixed effects for time periods, which is a very powerful design.
Yeah.
And I'm trying to present this to other people in the labor department and around the government. And you walk in and say the word regression analysis, and people's eyes go to. But I realized after the first time I presented this work that you can't use that word. Well, I started to think, well, what are we doing? And I realized since we had a balanced longitudinal sample, we were just taking a difference and subtracting off the difference. And it was just a difference in differences. So it was a regression. I did it with regression. We never actually calculated differences except to show people. So it was designed as a very simple, transparent way to show. I mean, everybody could understand.
Yeah.
Okay, you calculate this average and this average, you subtract them. Then you take this average and this average, subtract them, and then you subtract the 2. So we have 3 subtractions in a bunch of average. Anybody can do that.
Yeah.
And of course, it's an extremely powerful design. Now everybody uses it.
Yeah.
And it came to be called that. Difference of differences. It's hard for me to say where that really entered. I mean, Carter remembers the time when I first started saying that. And I guess it was probably when I came back from the government. We were still trying to get people to understand. What's other thing to remember is that, having micro data with person effects and year effects, that was pretty demanding. I mean, there's not very many data sets where you could do that.
Okay. So Shreyo, she says, 2 questions. Could you quickly tell us why you dropped the certain F years? Yes. So I dropped the F years because if you use this data set, okay, use this data set. I actually have 5 treatment dates. And I am wanting to illustrate this regression right here. I'm wanting to illustrate this regression where there is only 1 treatment date. There's 2 groups. There is a treatment group and there is an untreated group. So what I did was I dropped all the others so that it was, and that you're right. I should have done that. Oh man, that's a good point. I didn't notice that. Yeah, you are not supposed to put, and thank you. So you are not supposed to put in your post period the year of the treatment. It's supposed to be after, for reasons that we will see. 0.059, 0.0592543, 0.0592543. So we change it. But yes, we're going to see why Saray O'Shea's question is very on point. That is fatal. It is fatal to put in, and we'll see why. We'll see why. It's not fatal in this case, although the number did change. It's not entirely fatal because and I'll explain later, but it is you do not. You want it to be after treated. You want the base because you want this baseline to be untreated. We're gonna look at it right now. All right. Thank you. Thank you so much. So that's where it comes from. The phrase diff and diff comes from Orley Ashenfelter trying to communicate to non-social scientists, bureaucrats. Well, you just want, no, you only need 4 averages to calculate, I mean, how you need 4 averages. And you need those averages to satisfy what I'm about to talk about. I don't think I mean, probably you need the minimum number of observations such that your finite sample average is kind of roughly approximate to the population average. So but I don't know the minimum number per se. If you have 1 observation, 1 household, you could do diff and diff because diff and diff is 4 numbers. That's probably not very helpful. So we want to know what is this doing? What is this diff and diff equation doing exactly? Like, why would that be like why would this be here, this number? Why would this number right here be like, what is it? Because I know how it's interpreted. It's basically being interpreted as in the post period, this particular law is increasing homicides. So we need causality concepts. We'll get into that, Zod. When you start putting in covariates in, then it does it's not going to be as simple as 4 averages, 3 subtractions. This is all without covariates. Yeah, Sanjay, you're going to see it's gotten, in that sense, that part does not matter. You're going to be calculating averages. I mean, I guess the only thought I would say is, when is it that these sample averages are converging to their population means? That I'm not positive about that, but the fact that 2 groups have different numbers of observations is not itself, in and of itself, a problem, because you're going to be working with expectations the whole time. Let's look at it. All right, we're going to look at this potential outcomes model. So you're going to put here a job training program. That's the stuff Orley Ashenfelter was studying. It's like, you could think of a PhD as a job training program. All right, so it's going to be some kind of job training program. You're either in it or you're not in it. I is going to index a person at a point in time, T. Potential outcomes is distinct from realized outcomes. We're going to have to do a spreadsheet because even though I know there's a lot of people on the call that know this very well, there's a lot of people that do not know this very well, and we need to get everybody on the same page. So potential outcomes is going to refer to the same person in 2 different treatment assignments at the same point in time. All right. So like, for instance, Robinson has a set of wages today if he goes to college, if he went to college, and Robinson has a set of wages today if he didn't go to college. Right. So we have this like J is referring to two states of the world. The J refers to two states of the world, and the Y, when it is associated with the J, is talking about a potential outcome. All right, a potential outcome. This could be his wages if he went to college. This could be his wages if he did not go to college. Now, the usefulness of the potential outcomes is that it made defining treatment effects really, really simple. We just had treatment effects defined at the individual level, because remember what we said. Convert your research question into a causal parameter, right? Well, here's the core causal parameter in causal inference, the individual treatment effect. And the individual treatment effect, I call it delta. Delta I, it's at the individual level, it has an I subscript. And it equals Robinson's wages had they gone to college, there's I for Robinson, minus Robinson's wages had they not gone to college, but at the exact same point in time. Okay? And so you can't observe both of these because either Robinson has gone to college or Robinson has not gone to college. If Robinson has gone to college, then we know Robinson's wages under that scenario. If Robinson did not go to college, we know this one under that scenario, but you can't know both. Well, not at the same point in time. You could do it over different points in time, but the treatment effect is defined at an individual level at the exact same point in time, but two states of the world. And so we're missing the data. Okay, we're missing the data. We're missing one of them, right? So I went to college. I know my wages. Had I not gone to college, I would have earned this, but I don't know what that is because I went to college. This is a counterfactual. So we define this particular average of the individual treatment effects. Hold on. Sorry. Just checking the email I got. I just have to keep watching. So look at what we're going to do. We've got this individual treatment. We got 108 people on the call. All right. Let's just imagine that, 108 people on the call. Let's imagine all of them went to college. And the other 108 people, that's about right. I think it's 217 people that signed up. No, it's 232. So 232 people signed up. Okay. So we'll say 108 people on the call went to college, and we'll say the other 124 or whatever did not go to college, right? If all we did was average the treatment effects for every person on the call, we'd be averaging the treatment effects for the college students. College completers. We'll say that D equal 1. So this is the D equal 1 is always referring to a group of people. All right. And if you sort of imagine that all of the individuals have a treatment effect, even though you don't know what it is, because you're missing one of these two potential outcomes. If you went to college, you're missing this one. If you didn't go to college, you're missing this one. Right? So you can't actually measure it at the individual level, but you can define it at the individual level, and you can then define its average. You could say for the people that participated in the program, what's the average of their individual treatment effects? And we replace the delta with Y1 minus Y0, and we say for the people that went to college, everybody on the call, that's their treatment effect. And then we can just distribute the expectation operator right through these random variables. And we're going to say that the average treatment effect for those people on the call is equal to the average earnings for the people on the call, average earnings, had they gone to college, minus average earnings had they not gone to college. And this one, if everybody on the call went to college, we know that number it's whatever your wage is. You would just simply show me your pay stub. You would say, I make this, I make, $500. And then you go, all right, well, what would you have made had you not gone to college? And you go, I don't know. I don't know what that is. What are you talking about? That's impossible to know. Exactly. It's impossible to know, right? It's impossible to know, but it's not impossible to write down the equation for it. And that's the key part. The definition of it can be written down. And the definition of it is average Y1 for the treatment group minus average Y0 for the treatment group. So notice that is the definition of the ATT, and that is the definition of the diff and diff, and they are not the same. They are not the same. The diff and diff and the ATT are not the same. Now, potential outcomes are a priori real things, but nobody knows what they are. They're real because when you choose your treatment, then they occur. So in that sense, they're like real because they're based on whatever it is, whatever your choice is. And this is called the switching equation. And the switching equation would be like Sanjay, chose to go to college. When Sanjay chose to go to college, they set their D to 1. All right. 1 times Y1 is Y1. So let me just kind of make this simpler. We go here. See, whoops. Y equals Y1 plus Y minus 1. Right. So I can just kind of put this stuff here. I can go, 1. I can go minus 1. Right. Well, 1 minus 1 is what? It's equal to 0. So it knocks it out. And so you can see here that if you go to college, I will observe your Y1. And if you don't go to college, then, well, that's 0 times that, so that goes away. 1 minus 0 is a 1, so that, we can just simplify that. And if you don't go to college, I observe your Y0, all right? So the realized outcomes are the left-hand side variables. These are like your actual data. And the right-hand side Y's are the potential outcomes, and they get eliminated. They get chosen, and they also get eliminated by whatever choice you make. And how those choices get made is called the treatment assignment mechanism. And that's what the treatment assignment mechanism is what ultimately drives whether or not you can use difference and differences. Okay. So let's real quick. All right, we're going to take a 15-minute break. We'll be right back. And we'll do a little quick exercise. We'll be right back. Okay. There's a lot of conversations in the thing. I think that a lot of it's getting answered, but I just want to make sure. Okay, Renz, we're going to get to that tomorrow. I'm going to hold off on control groups, covariates. Pablo, we're about to cover this part. Okay, good. That's it. So we're about to start now. We're about to start now with this exercise here. Okay, I'm going to share it. People already there. All right, good. So I got people in the chat. I'm going to help them out. Okay, I'm going to put in day 1. You know what? I'm going to have a exercise. I'm going to have a group exercises. I'm going to put it in exercises here. You can see it down here at the bottom. Put it put it like right there. We'll put it right there. All right, that's where that's where it's gonna be. But I'm gonna stay in day one. I'm just gonna stay in day one, where I can hear y'all. All right. So we're gonna go to which one were we on? So we were on weights. Okay, weights. Yeah, good. All right, weights. So we're only gonna do weights, and you're gonna need to copy this because I think I just gave you viewer access. So you're gonna need to copy and paste this onto your own side so that you can understand what we're doing. All right, what we're doing. So I'm gonna just put this up here. Okay. And all we're really going to be illustrating here is defining treatment effects, defining average treatment effects, switching equation. All right. So that's really the main thing. So we're going to define. So here we have 11 patients. We have 11 patients that are going to the doctor for depression. And the doctor, okay, so each person has a potential outcome. If Andy takes a drug for his depression, we'll just call it happiness, his happiness will be a 14. If he undertakes this alternative treatment called mindfulness, it's a form of meditation, he'll get a 15. All right. Now, we're going to describe that these are the only two things that exist. I mean, he could just literally not have anything, but we're going to talk about the treatment in terms of comparing two states of the world, right? So we're going to say, y1 minus y0, okay? We're going to say y1 minus y0. Why? Because y1 minus y0 is the treatment effect. Treatment effect. That's what the TE means. So if Andy gets on a drug, Andy's happiness will be 1 point lower than the counterfactual, which would be on a mindfulness. It hurts him. The drug hurts him relative to mindfulness. Relative to mindfulness. He's still got happiness, but it's not as high as it would have been had he been on mindfulness. So then we do another one. Betty's happiness on the drug is a 15. Betty's happiness on mindfulness is a 20. So look, her happiness on the drug is actually higher than Andy's, but her harm is a -5. Her harm is a -5. So even though her happiness on the drug is higher, her happiness under the mindfulness is even more higher. So her treatment effect is a -5. Chad, -1. Daniel, -6. Edith. Edith is helped by the drug, by a lot even. Okay, she's helped by a lot. Frank, helped by a lot. If Frank is put on the drug, his potential health outcome would be a 15. If he's put on mindfulness, his potential happiness is a 2. So the causal effect of the drug on his happiness is a positive 13. We can do all of these. George is not helped. George's depression is not going to be helped by either one of those. Hank's is going to be hurt. Ina's is going to be helped. Kelly's is going to be hurt. Mindy's is going to be helped. All right. So all we've done is we've gone through at the individual level and we've defined treatment effects. Now, they cannot be on the drug and the mindfulness at the same time. So here's what the doctor's going to do. The doctor is going to, first we're going to calculate the average treatment effect. So what we're going to do the average treatment effect is just average column D. Hit X, don't do that. So the average effect of drugs is to increase happiness by 2, even though there's a bunch of people that it hurt. Heterogeneous treatment effects. Not everybody. In fact, nobody's treatment effect was a 2. Nobody's treatment effect was a 2. Okay. Now we're going to look at the effect of the treatment effect, average treatment effect on the drug group. Because if you look back over here, there's a thing that we can calculate. We could calculate an average for different populations where the population is referring to the treatment status. But see, we've not defined the treatment status. So we have to come up with a rule. There's all kinds of rules that we could use. You could say only give, it's just a doctor. Doctor does not know those potential outcomes. They may have like symptoms, and then using the symptoms, they could assign one, but they don't ultimately know. So let's just come up with a rule. Let's do, if it's let's do the first 7 are going to be on the drug. To Edith. And then the rest are going to be on the mindfulness. All right. So now we're going to calculate the average treatment effect. Did I do that right? That's interesting. I wasn't even planning that. Yeah. Let's do a little bit more. We'll go right here. All right. So we'll go there. Actually, I liked it better the other way. All right. So there. Yeah. You know what? Let's do it. Let's do it like this. Okay. So we'll go, because I kind of want this just to look like something that shows some heterogeneity. So we'll do. All right. So for the drug group, if the first 4 people constitute the drug group, then the average treatment effect for the drug group is a negative 3.25 on average. That's the ATT. This is the ATT. We could calculate the ATU also. And that would be the average treatment effect for the people on mindfulness. And clearly the people on mindfulness on average have very high treatment effects for being on drugs. It's almost like the opposite. See, like this here, this is saying if you're on drugs, what was the impact of being on drugs? It caused your happiness to go down by 3.25. If you were on mindfulness, what was the treatment effect, the average treatment effect of being on drugs? Well, if you had switched these people over to drugs, their treatment effect would be higher. So in some ways, whoever did this did a really bad job. They're kind of giving them to the wrong thing. Okay. Okay. So now let's do the switching equation. Right. And the switching equation is, I think I got it right here. Well, nope, I don't have it. So we'll do the switching equation equal D times Y1 plus 1 minus D times Y0. Okay, so look what's happening. So if he's on the treatment group, well, that's the treatment. That's the treatment. That's the potential outcome associated with that treatment status. It's a 1. It's a 1. So if he's on the treatment group, I observe that number. That's what so if he took the drug, I'm going to look at his, if he took the drug, I'm going to look at his health. All right. I'm going to look at his health and he's going to be like a 14. If he's on the mindfulness, I go over to the Y0. It's a 1. He's going to get a 1. Okay. He's going to get a 1 for why? Because people on that's his, that's his potential outcome on, the mindfulness. All right. Well, here's what I want to show you. I'm going to take the average of this whole thing right here. And what that is I call that pi. And this is the percent of the population on drugs. It's just the average of this. This is what I want to show you. Equal ATT times this plus ATU times 1 minus this is equal to 2. So the weighted average between the ATT and the ATU is just equal to the average treatment effect, okay? Multiplied by a weight, okay? All right, so let's write down Orley's 4 averages and 3 subtractions. 4 averages and 3 subtractions. We're going to use 2 groups. Yeah, we'll do a spreadsheet. So what we're going to go until lunch and we're going to get this spreadsheet done, right? So we're going to have 4 groups, 3 subtractions. We're going to write this down. There it is. Average Y for the treatment group in the post period. Average Y for the treatment group in the pre-period. Average Y for the comparison group in the post period. Average Y for the comparison group in the pre, right? So that's the diff and diff equation. You can estimate it with a regression. What we're going to do now, we're going to use that switching equation. Remember the switching equation? Switching equation said, depending on your treatment status, depending on whether you're treated, is your realized outcome a Y1 or is it a Y0? So if you're treated, it's a Y1, and if it's not treated, it's a Y0. So what we're going to do is we're going to replace post-period, treatment group, treated. Pre-period, treatment group, not treated. So therefore I observe Y0. Comparison group, post-period, Y equals Y0. Comparison group, pre-period, Y equals Y0. All I did was replace Y with the corresponding potential outcome using the switching equation. Y equals dy1 plus 1 minus dy0. That's all I did, right? So I said, you know, in the post period, the treatment group is treated, so that's a 1. That's a 1, so Y equals Y1. Y1. If it's the pre-period, it's the treatment group. It is not treated, so Y equals Y0. 0, 0, Y equals Y0. And if you're a comparison group and you were always untreated, then Y equals Y0, right? So then I replace that. That's the diff and diff equation, but I use the switching equation. Now what I'm going to do now, is I'm going to add in a 0. You can always add in a 0. So this diff and diff equation, that number, is equal to 4 averages and 3 differences plus a 0. Zeros don't do anything. But this is a special kind of 0 because it's going to be expectation Y0 in the post for group K minus expectation Y0 in the post for group K. Now that's counterfactual because in the post, group K was treated, but this is in the post, group K not treated. But that doesn't exist. Doesn't matter. Doesn't matter if it doesn't exist. We can still write it down. It is real. It's a real term. It just would have occurred had he not been treated in the post. Well, now we've got 6 variables. Okay, 6 variables. And we're just going to, and they're all being like, it's linear. So we're just going to move some stuff around. So we're going to move this. We're going to replace this term right here with that entire term. So this is going to move down. This is going to move up. So look at what diff and diff is equal to. Diff and diff, the diff and diff estimator, is equal to average Y1 for the treatment group in the post period minus average Y0 for group K in the post period. average Y0 for group K in the post period. So diff and diff equals the ATT. If you go back to what we did before when we did this origins of the public health stuff, look what we had in there. We said diff and diff equaled the ATT plus, it equaled the ATT. So it was in there. When we did this Lambeth and Suffolk things, we said it equaled the treatment effect. So there's that D part, plus this. And what is that? That's this. It's two trends. Only one of them's in red, and one of them's not in red. So look what this trend is. The diff and diff will equal the average treatment on the treated if this entire second row is 0. When will this second row be 0? If the change in Y0 for the treatment group over time is equal to the change in Y0 for the comparison group over time. It's just that is counterfactual. That did not occur, right? We saw it here in this 3 waves of diff and diff. When Josh Angers drew this picture, and he said, excuse me, he said, he drew a picture like this, and he was like, this is the post-treatment for the comparison group. This is the pre-treatment for the comparison group. That's the post-treatment for the post-treatment for the treatment group. Got the thing? And this is the pre-treatment. So, hold on. So he says, here's a treatment effect. And if this trend and that trend are the same, then something will identify the treatment effect. So it's a trend. It's a counterfactual trend. And so what diff and diff is at its core, at its core is 4 averages, 3 differences. And if this counterfactual trend is equal to this real trend, counterfactual trend, real trend, then diff and diff will equal this. And so what you need for diff and diff is you do not need randomization. You need for 2 groups, the treatment and the comparison group must have the same trend in Y0. The evolution of earnings for our trainees would have been the same had the trainees never been trained. This is why, go back to this statement here. Early identification by Blundell was a form of strict exogeneity based on panel data, but this was viewed as too strong. Why? Athey and Ibn say, note that the full independence assumption is stronger than is necessary for diff and diff to give the average treatment effect. What are they talking about? What they're talking about is this. You don't need strict exogeneity. You don't need a regression model. All you need is parallel trends. All you need is for the observed trend in Y0 for the comparison group to be equal to the unobserved counterfactual trend for the treatment group, Y0. And if it does, then that simple method, diff and diff, will identify the average treatment on the treated. And if it is not, then it won't. It'll be biased. This is the driver of the unbiasedness of diff and diff. Okay, so parallel trends does not mean that treatments were randomly assigned, but if you had random assignment of the treatments, it would guarantee parallel trends. In applying the diff and diff framework to the data, it is important to consider carefully the experiment created by these court decisions. In the ideal case, court decisions would be independent and random. But you don't need it to be independent and random. So parallel trends does not require random assignment, but if you had random assignment, then parallel trends would hold. It does not require that the groups be similar at baseline on outcomes. See how these are different in levels? In levels, they are not the same. So what we're saying here is that parallel trends does not require that the groups be similar at baseline. It requires that their trends from baseline to post be the same. But one of the trends, one of the observations needed to calculate that trend is missing. No, Anna, we're going to see it's the same. It's the same. We're going to see it in a minute. When we go through OLS, we're going to see it. All right. So here's your first homework assignment. We'll go over it tomorrow. This is on slide 58. Okay. Now, what we did was we said switching equation. We said we had a diff and diff. All right. We said this. We said I have a diff and diff, and I've got a 1 here and a 0 here, and I got a 0 here, and I got a 0 here. Okay. And when I do that, I can add in a 0, and I get the ATT plus parallel trends. Okay. What if you're using a comparison group that is treated? Correct, Waldo. The difference in levels does not tell us anything about the parallel trends assumption. That's correct. It does tell us that they're very different. It does tell us that very different groups, you know, so they have very different, they appear to be different on for some reason, like covariates. So you might say that you are not as confident in the parallel trends assumption because they are so different from one another. But technically speaking, differences in baseline levels on the outcomes is not the same thing as differences in parallel in trends. Okay. But what is the homework going to be is it's going to be what happens if I compare in a diff and diff a treatment group going from 0 to 1 to an already treated group that was always treated. If I do that, and that's not a 0, that's a 1, okay? And you're going to be adding in a 0. So the question is, you know, it cannot be, if you change these two, that won't be the same. So what I want you to do in your homework assignment is work through and tell me, what does the diff and diff equal if you have an already treated group as a control? I want you to work it, and we'll do it at the beginning of the day. I want you to replace realized outcomes with potential outcomes, rewrite using the add 0 trick we did, and I'll review the answer tomorrow. Take a stab at it. Work it out. For the next 20 minutes, we're going to now, before we move into regression, because Anna asked about the regression models. All right. So what we're going to do is we're going to go through a simple exercise to really pin down these core ideas with some simple calculations. All right. So here's what we're going to do is follow these instructions. Got them down here. All right, I got them down here. So first thing what we're gonna try to do basically in this is we're gonna do the same kind of thing we did before, where we're gonna decide what is the pre-period, what is the post-period. We're gonna then decide if units are treated in that period or not. We're gonna use the switching equation to fill out this column, and then we're gonna calculate a diff and diff manually. Then we're going to calculate the average treatment on the treated in the post period, because if you look back to what the ATT was, remember what the ATT was, it was average Y1 for the treatment group in the post minus average Y0 for the treatment group in the post. So we're going to kind of like, do all that. We're going to see, we're going to calculate the ATT, and we're going to then see if it's biased. All right. So let's do that together. All right. Post period. Group 1 is going to get treated in 1986, because it says that here. Mark pre and post period depending on when group 1 was treated, which was 1986. We're going to go to column G. So it's not treated here. All right. But it is treated here. And pre, if you look back here, pre and post, it's always the same number. It's the same calendar year, because it's the pre-period refers to when group K was treated. So we're going to put back in pre. And then for group 2, even though group 2 is not treated, it is the post period for group 2. All right, it is the post period for group 2, because it's 1986, 1990 is the post period. It's after when group 1 was treated. All right, that's first step. Second step is going to be calculate the ATT, put it in J7, interpret it. J7 is right here. Okay, so remember what the ATT is. Average Y1 in the post equal average Y1 in the post. That's the post. That's Y1. Minus, what is it else? Y0, average Y0 in the post. So we're going to put an average Y0 in the post. We're going to X that out. So the ATT is 30. All right, ATT is a 30. Now we got to figure out the treatment assignment. All right, we got to figure out the treatment assignment. So in the pre-period, nobody is treated. In the post period for group 1 is treated. But group 2 is not treated in the post period. Is not treated in the post period. Okay? And now we use the switching equation. We need to go from Y1s to real data using the switching equation. And the switching equation is right here. Y equals dy1 plus 1 minus dy0. And we're going to write it in. Equal d times y1. Didn't put it there, but it's not going to matter. 1 minus d times y0. Fill it all the way down. This is our data. Oh, it didn't do it right here. I don't know why. Huh. Oh, it's doing something weird.
It's got for group 2 post.
Oh, it should be this. Thank you. Thank you. I didn't see that. Oh, good. Okay, they were always supposed to be untreated in the post. The comparison group, remember, is untreated in the post. So they're untreated. All right. So we filled in the realized outcomes with treatment assignment F and the potential outcomes using the switching equation. And now what we're going to do is we're going to calculate 4 averages and 3 subtractions. All right. We're going to calculate average here. We're going to use this information right here. Post pre averages of Y. So we're going to go equal average Y for group 1 in the pre, equal average Y for group 2 in the pre, equal average Y for group 1 in the post, equal average Y for group 2 in the post. All right, so what I've got now is I've got numbers. Group 1 in the post. Group 1 in the post, 41.56. That's a 41.56. Group 1 in the pre, it's a 6. So when I do the first difference, I should get 30-something. 35.51. Now I'm going to go this number, which is an 11.59, minus that number, which is a 607. And I'm going to put it right there. Okay. So now I have 2 subtractions. I have 4 averages. 1, 2, 3, 4. I have 2 subtractions. And I'm going to do the last subtraction here. Equal first treatment group difference, which is there, minus the comparison group difference, 29.99. It's biased. Okay, it's biased. So, if you look back here, we could actually just take the truth. We could take, let's see, we could take diff and diff minus ATT. So I could say diff and diff minus ATT, and that'll tell me the bias, okay, which will be that number. So we'll do that now. Equal diff and diff minus ATT, negative 0.01. Oh, gosh. Anthony's right. I messed it up earlier. The dummy for post needs to be all of the treated periods. I'm sorry. It was right the first time, and for some reason, when that question was asked, I got a little spaced out. It needs to be that the dummy variable is including only treated periods. It's the post-treated period. Yes. That's right. Thank you. Anthony brought that up. So it actually needs to be that. Okay. I'm sorry. I'm sorry. I usually get this right, and I had it right the first time, and I just spaced out. Yeah. So no. 1985. It's treated in 86. So those are pre-periods. 86 is the treated period, and we're going to call it the post-treatment because it's after the treatment occurred. Thank you, Anthony. That was a good clarification, and that reminded me that I had made the mistake earlier. So post needs to be in the, it is the treated period. Okay? It is the treated period. All right? Okay, so we've got the bias. We've got the bias. The bias is negative 0.01. But so that means that the bias is actually equal to our parallel trends term, or what I'm calling non-parallel trends bias. So let's just calculate it. And what's interesting is look at what parallel trends is. It's a diff and diff equation. It's 4 averages and 3 subtractions. So let's just calculate the 4 averages and 3 subtractions right here. Equal average group 1 pre. But we're not working with the diff and diff stuff. We're working with the ATT stuff. We're going to go here. Now, Because it's not treated in that period, y equals y0, so those numbers are exactly the same. Okay, go to group 2. This is going to be pre-period group 2 y0. Okay, so we've got pre-period group 2, pre-period group 1, and then we'll do post-period group 2. We'll do that. Post-period group 2, that should be here. All right, so notice 3 of the terms in that bias term we could calculate. It's that one we can't calculate because that one is y0 in the post. It's this part right here, but see, those numbers are not the same as those numbers. Those numbers are not the same as those numbers because in the post period, the treatment group is treated and we skipped over to y1. y1 became the realized outcomes, but the bias term is based on y0. Let's calculate it. All right. So now we get y0 in the post minus y0 in the pre. And then we get y0 in the post minus y0 in the pre. And we do our diff and diff equation for parallel trends. Whoops. Parallel trends bias. Diff and diff equation for parallel trends bias is what? First one minus the second one. Equal this minus this. -0.1. The parallel trends term is the bias of diff and diff. Parallel trends term is the bias of diff and diff, where the target parameter is the ATT. Okay, it is the ATT. So what assumption does diff and diff need? The bias happens to be equal, happens to be equal to group 1 minus group 2 for pre-period. No, it's this. It's the change in y0. It's the change. It went from 606 to 1157, and this went from 607 to 1159. We calculated it as the change in y0 minus the change in y0 for group 2. So see, it was change. It wasn't this. It was not this y0, y0. That was the conversation that was brought up just a second ago. Waldo 21 says, does the difference in levels not tell us anything about parallel trends? Right. And so, you know, that would be this. That's not it. In our example, the way I did it, it did do that, but like that's not ultimately it. Yeah. So the bias of diff and diff, is just diff and diff minus the ATT. And if you subtract ATT from both sides, you'll get diff and diff minus ATT, and it is equal to that term. And that term is the non-parallel trends bias term. And so since this was a 29.99 and this was a 30, that had to be a -0.1. And the reason why it had to be a -0.1 is because diff and diff is by definition equal to ATT plus parallel trends. It's not a theorem, it's an identity. Okay, it's not a theorem, it's an identity. It came from the definition of the diff and diff and the switching equation and then adding in the 0. It's just that if you're using a not treated comparison group, those are y0s. And when those are y0s and you add in those y0s, it just becomes diff and diff equals ATT plus all of that. Yes, treatment begins in the post. Post period includes only the treated periods. Pre-period includes only the untreated periods. Sorry, I messed that up by that question. I don't know why I did that. Okay. Okay. So there are 3 assumptions to diff and diff. There are 3 assumptions to diff and diff. The most commonly known one Okay. The most commonly known one. No, you don't, Reese. If the treatment starts in June, oh, no. We're going to see, Reese, on homework assignment number 2. The pre-period must be untreated. Pre-period has to be untreated. Okay. Post-period, whatever you do, you could drop 86 from the data. It'll change the ATT parameter. So like, I mean, if you did drop it, you'd only be identifying the ATT for that period. If you did that, so you'd be like C10. And it's a different parameter at that point. It's, so I mean, these are kind of getting into judgment calls. If you're comfortable doing that, and you want to say, I only want my parameter to be, I mean, that would be correct, actually. Reese, that would be correct. There's supposed to be, under an assumption we're going to talk about, no variation in what a treatment assignment means. If it means a 0, it means a 0. If it means a 1, it means a 1. Most of the time, people don't I've never seen anybody drop it personally. But to your point, yes, it would probably be technically accurate. Yeah, Alexander's right. You can calculate it for different windows. You could do it. You could totally do it. And then it's like if you did it for different windows, then you've sort of changed the treatment itself. Yeah, so this is a good place to stop and for us to kind of pause actually here. So you could. So this is a good place to kind of stop. So basically, you could cut things in different ways. It will change the parameter though. That's the whole thing. Alexander's saying you could calculate the ATT for different windows. It would be an ATT for those windows, right? It would be an ATT for those windows. I'm not, I don't, that is that coming from Epi, Reese? These Epi versions of these things? Yeah, remind me what consistency means again. Does it mean that the treatment is always the same? Define the same? Consistency? I bet it does. Yeah, probably, Reese, it would do it. In the language that we're going to describe it, it's called SUTVA. And under the stable unit treatment value assumption in Imbens and Rubin's book, they define, it sounds like what they call consistency. In EPI, they're calling it SUTVA by Don Rubin, and it means there is no hidden variation in the treatment. So if you are treated, if being treated means treated for 12 months, it means treated for 12 months. Yeah. Well, these are kind of getting into very specific applications. Okay. Okay, so technically Tandem says, do we assume the treatment started from January 1st? So the answer is yeah. Technically, yes. It's tricky when you have, like, it's like Shreya said, it is. Yeah, I will. I'll give you more examples of SUTVA. But technically, yeah, like you are, that is what you're assuming. You are assuming that that whatever it means for Nia to be in the treatment group, to whatever it means for Nia to be treated, and if I'm treated, it means the same thing. So like in the medical trials, it's really straightforward. If Nia gets 750 milligrams of some particular medication and she's in the treatment group, or they're in the treatment group, and I'm in the treatment group, and I've got to get 750 milligrams also. So a lot of this comes from the medical literature. And so they require under SUDFA that the treatment assignment correspond to the same dose. We're going to talk about continuous doses later on the fourth day, but SUDFA, but even then when we do that, it doesn't violate SUDFA. So so yeah, I think that this is a good point. And I'm with Alexander. We're going to see this. Yes, exactly. Hoekstra does that. Hoekstra basically uses a continuous treatment. If you think about it, he's using a continuous treatment. Zero, in that year, it's half a dose. So you could do something like that. Then the question is, what is the correct estimator for the continuous dose? Because if you are doing that, Shadi, if you are doing that, then you're gonna have that, like, post is not gonna be a 1. It's gonna be like some half thing. You'll get some kind of defined parameter. That'll probably be fine. I mean, these are all really great questions. I don't know why I've done this so many times, but nobody's ever asked these questions. When we come back, we're gonna come back in an hour, and we're gonna talk about these assumptions a little bit more in detail. So let's come back in an hour at 1:05. All right. And I'll see you guys in an hour, and then let me be thinking about these questions. And you can be asking questions in the chat. So I'll see you guys in an hour. Sorry about that. A couple of minutes late. Let me look. Let me see what I missed. Okay, yeah, Christian, we're all in the, okay, here's the deal. Here's the deal. Okay. I was thinking of this in the car. All this questioning is good. All this questioning is good. It shows that we are all in a place where we have lots of questions, but it's about the correct questions. And, I've kind of got this flow, but you're like, y'all are all getting it. So, and you're asking the questions and you're getting it. So, I want to like answer them, but they're like, can't quite get to them yet. So keep asking the questions. Keep asking the questions. Yeah. The year the treatment begins is post. Waldo, correct. The year you're good. So here's the deal. This is going to be the homework assignment where you will convince yourself. All right. You will convince yourself why it is the case. Here's what you'll convince yourself. So with this one, homework number 1, all right, what you're going to be doing is you're going to be going, treated in but compare U group treated both periods. You're going to go 0. You're going to go 0. No. 1, 1, 0, 1. And then what your goal is to get to an average treated on the treated. All right. Now, I'd like you to add zeros in until it looks like something interesting. Okay. I want you to, for all of these, add in 0. Here's what I want you to do. add in zeros until you have a parallel trends assumption. Okay. So then for this one, because it won't be immediate, you won't get one immediately. It's impossible, right? Because here, in order for this one to only have a parallel trend assumption, they all have to be zeros. So that means if this is 1, 1, what I want you to do is continue to add in the correct kind of zeros until it's an average treated on the treated plus a parallel trends. There's a parallel trend assumption in there. Diff and diffs always have a parallel trend assumption. So you're going to search for whatever else is there. And then for this one, which is this no anticipation stuff that we're about to start talking about, what you're going to do instead with this one is you're going to go 1, 1, 0, 0, which is what we've been talking about, which is like Waldo's saying, does the post need to be treated? Yes. Does the pre need to be treated? Well, we're going to find out. A lot of this we're going to find out ourselves, okay? Or all of this we're going to be finding out ourselves. So then that's what you're going to do. But what the goal of this is to basically do the manipulation like I did here. This one was simple. Do the manipulation until you get to average treated on the treated, parallel trend, and what you got to go. You got to keep going until you get average treated on the treated and parallel trends. You might get some more though. You might get some more. All right, so there's 3 main assumptions to diff and diff. The one everybody knows about is parallel trends. But actually, and this is what we're going to see tomorrow, parallel trends is nested within a bundle of other assumptions. See, you can see it right here. Parallel trends needs the baseline to be untreated. And it needs a comparison group to be untreated so that we have 3 zeros. When we have 3 zeros, diff and diff only needs parallel trends. But see, look, there's the baseline untreated. There's the untreated comparison group. So those have 2 meanings. The first one, the 2 lesser known assumptions are called no anticipation, or NA, and the stable unit treatment value assumption is a version of it. I've kind of butchered it a little bit. We'll explain what SUTVA is, but here, no anticipation means simply that the unit is not treated until it is treated. That no anticipation means that the unit itself is not treated in the past unless the treatment is occurring in the past. Okay? And that can be violated. For those that have an economics background, economics almost forces no anticipation to never hold, if you think about it. Like, I win the lottery today. All right. But I don't get paid until November. I'm going to go buy a new house today. I'm going to go get a jet today. Nobody is going to have any problem. No banker is going to have any problem loaning me millions of dollars once they see my check that says an IOU for the lottery. So, my behavior is getting changed as though I was treated already, because I am getting treated in the future. All right. That would violate no anticipation. And we'll talk in a minute. I know what you guys are thinking. You'll say, well, why don't we just do this one thing? And I'll get to that. But sometimes no anticipation is not getting violated, even though you know something's coming. So, like, for instance, let's say that a state like Texas lets you drive without a driver's license. All right. In a year, they pass a law that says you no longer have to have a driver's license to drive a car. And that law is coming in a year. And therefore, people are going to be driving cars in a year No anticipation cannot be assessed. It cannot be assessed. It is not testable. If you think it is violated, you need to roll back the treatment date. Okay? If you do not think it holds, you need to err on the side of caution and go back until you're positive it holds. In homework number 2, you will see why that is the case. You have no choice. After you do homework number 2, you're going to be like, yeah, that's right. I have to do this. Okay, so a state lets you drive without a driver's license, and you know it. You, of course, in the future, you're not even gonna want to go outside, right? You're not gonna even want to be a pedestrian because there's gonna be a bunch of people driving around that are like 12 years old that don't know how to drive a car, right? But that doesn't happen until a year from now. No anticipation isn't changing your behavior now. Sorry, that future event is not changing your behavior now. So what no anticipation means is that there is no treatment effect until there is a treatment. And if the anticipation of the treatment is creating a treatment effect, then you got to go back in time and make the baseline that point where it is impossible. And what some people do is they just say they'll use as their baseline the announcement date. Then you could use an event study, Amy. Then you could use an event study, and you could say, all right, the announcement date is actually T-2, and now I'm going to do event studies, and I'm going to see if there's any treatment effect in T-1, T=0, T+1. You know, you can sort of check. And if there literally is no treatment, you know, in that year, you're probably safe. Okay. But it's still like, I would say, I don't know if I would say that there's not, you know, I don't know if I would probably, I mean, if you believe that it is treated, that's the whole thing. Okay. The whole thing is, if you really believe that it is treated at T-1, even though the law does not start until T=0, you gotta make it T-1. You got to, because it was treated. Exactly. Yeah, that's it. Renz, you do. Exactly. It's going to change a little bit of the parameter. It's going to change a little bit of the parameter, because especially if it's muted, or there's like, you know, maybe not really much of an effect, you know, at T-1, you could still do the event studies. Amy is right. So to Amy's point, Amy is correct that like the event study is a nice way of getting around it, because event studies always just estimate for that year the treatment effect. So it'll always be in that year, in the T-1, you'll estimate a treatment effect that's for the T-1. It's the aggregate parameters that get a little bit funky. I don't think you ever throw out data. I think it gets wrapped into the post period. I think it gets wrapped into the post period. That's what I would do. And in fact, I might kind of like use the event stuff. I mean, I could imagine this. I mean, I get a little non-committal. You guys are going to notice that I will get non-committal on these questions. And the reason I get a little non-committal is because sometimes I think they like don't have an exact answer. Trevor, right. Do both as a robustness check. That's exactly what I was getting at. It's like, you know, because I mean, I could easily imagine doing both, going like, here's the effect if it's at T-1, and here's the effect at T-2. It's going to change the parallel trend assumption, but you know, it'll be the parallel trend assumption will always be with respect to whatever that baseline you've chosen. But if I kind of did it and I did the event study like Amy did suggest, sorry, Amy, I kind of like said no, and now I'm saying yes, but like to your point, you know, yes. Okay. So I kind of overinterpreted what you said, probably to say, can it be completely true? And what I meant was like, this is what I meant to Amy's question. What I meant was like, this is what's not testable. Is it a 0 or is it a 1? Okay. Well, the thing is, it's one of them, can't be both. And it is one of them based on treatment assignment. The only thing that lets you know what this is based on treatment assignment, right? And so event studies do not tell you if it's 1 or 0, but this is the part where I was kind of like, saying, all right, well, but like we do this all the time. Is there evidence for it being an okay baseline? And that's where I was like, yeah, probably I would do the event study. And I would like say, let's make it T-2. Do I find a treatment effect at that T-1 where the announcement occurred? If I do, then I would be like, especially after homework number 2, if I do, I'll be like, yeah, on the safe side, I'm going to make it T-2. And the aggregate parameter will be one where it's basically combining the announcement date and the effective date. As long as you're super clear about that, as long as you're super clear about that, about what your parameter means, I just kind of feel like as long as you just say, this is what my parameter is, and you like use proper description, I kind of feel like you get to do whatever you want to do. You know, you say, my aggregate causal parameter is the average treated on the treated that's combining some weighted average of an enforcement effect and an announcement effect. Okay. And then a person's going to go, all right. And you can go, I did a robustness check, like Trevor said, where I actually did do just the effective date. It didn't really matter. Doesn't really matter. And that's where people can kind of like, reasonable people can kind of go like, you know, Renz might say, well, I did, it didn't matter. I'm going to do it T-1. And then like Amy might go, you know what though? I'm going to be on the safe side. And I'm going to make it T-2. As long as you're able to fully follow all the necessary assumptions to justify it, it's cool. That's all I care about. Okay. Sorry, I kind of went on a rant there. So, but these are all such good questions. I'm kind of excited. So, Sutva, no anticipation. I have a couple of Substacks on it, but here, second assignment is going to be the Substack. This is what we're going to find with the no, you know what? You're going to do it yourself. That's peeking. You're going to find something like this. I'm not going to show you what it is, but you're going to find something like that. All right, Sutva. What is Sutva? Now, technically, Sutva means no interference. What does that mean? No interference means that when this unit, like so say Amy gets treated with a college degree, that does not cause Harsha to get a college degree. Whatever the like there can't be these like spillovers or interferences. It's meant to say this. It's like the because you have to kind of like imagine a randomized experiment. And so they're supposed to be like keeping these things separate. So a treated unit cannot impact a control unit such that their potential outcomes change. You're only treated if you're treated, right? You're only treated if you're treated. So it's kind of like we've done this. It's like imagine this. Like I do an RCT, and Harsha gets randomly assigned the treatment. Treatment is get a college degree. But then like Amy like wants to go to college because they're like, maybe they're like twins. And Amy's like, well, I want to go to college. And so then Amy's like, I'm going to college. Well, it's like, that was interference. Okay. You have to rule it out. And that's why I was calling this one a version of Sutva, because what we're going to have is this. The treated unit is going to get treated. Now, technically, the treated unit is already treated, but technically this would be Sutva. This would be a Sutva violation. When this one got treated, it caused this one to get treated. Well, not really, not placebo effect. It just means that It just literally means that there's like no externality between the units. So Sutva really like starts to matter because what happens is that Sutva starts to change these things, right? They start changing these things. And the reason why that matters is because, you know, the only reason this gets to the diff and diff, you know, the only reason diff and diff gets to this parallel trends is that that's a 0 and that's a 0 and that's a 0. That's no anticipation. That's Sutva. Okay. When you have it, all you need is parallel trends. Okay. Well, when you don't have it, then that's a 1. And if you violate Sutva, then that's a 1. And if you use an already treated control, that's a 1. Both of them are 1s. So what we're trying to understand by going about this is what we're trying to understand is, yeah, I gotta give you all the answers here. Okay, yeah, I'm not going to give you the answers because we're going to do it. We're going to review all this stuff tomorrow. What was I thinking? So, secondly, no interference. Does no interference mean for both the outcome and assignment of treatment? It means that when well, so Saban, that would be an example of it. That would be an example of it. So like, why? Because the only reason that the outcome changed was because of the treatment assignment. So it doesn't really matter the path. It just means that if that person is treated, does it change the potential outcome of the untreated unit? That's the deal. And that is what we have to rule out. And with diff and diffs, like that stuff can happen all the time. It can happen all the time. Because, you know, imagine that you're using as your treatment groups neighborhoods. Okay. And like in an extreme case, like the city passes an ordinance where certain neighborhoods are going to get heavily policed and certain contiguous neighborhoods are not getting heavily policed. Okay. Then the contiguous neighborhoods are probably going to also get treated. Because like, you know, even in the nearby neighborhood, they're going to be like, the police are kind of close by. So got to be careful. Or the other thing could happen, which is that the robbers are like, the police aren't here. And so I'm going to rob the neighbors next door because I don't want to be over here. Like either one of those would be interference between the treatment status and the potential outcome of the untreated group, which means that you get around these things, not by not running diff and diff, but running diff and diffs where you ensure that Sutva holds, because what you've got to do is you've got to be sure that that is a 0 and that's a 0, right? Well, how do you assure that that's a 0 and that's a 0? Well, that's a group that is not treated. If it is a group that is getting treated, drop them. Drop them from the sample. They cannot be used. They're only going to screw stuff up. No hidden variation in treatment. This is the kind of stuff we were talking about. When the units are indexed to receive a treatment, their dose is the same as someone else with that same index. That gets violated in lots of situations, but this is all about working with binary treatments, that the binary treatments kind of refer to the same thing for all people, right? Who receive that dose. So it's kind of like saying that if you are in the treatment, if me and Dream Chaser are in the treatment, that means we're getting the same dose of the treatment. That's, you know, so that can get violated a lot. Sometimes, you know, you gotta like, but you know, I mean, it's like with diff and diffs, it's all, I mean, it's just, it's hard to enforce it with laws. So, you know, lots of times people kind of just sort of like, I'm not gonna be able to study it if I don't allow some of these things to be grouped. And that's like the practical answer, you know, it's like things get grouped together. And I mean, sometimes what you got to do is you just have to be really clear. But, you know, maybe you have robustness where you drop things. Let's see. I mean, cluster. Yeah, interference. Yeah, probably Dream Chaser. Yeah. I mean, if you ever like, so Dream Chaser asked this question. So, if people are offered the same amount of treatment, but choose, no, he said, does that mean treatment and units and control shouldn't be in the same cluster or village? Yeah. You know who's good about this is the development economists. When they do their RCTs, they'll go to such limits. They go to such extremes to enforce SUTVA, where they're like, if they have to go pick up their vouchers, like maybe the RCT is a voucher and they have to go pick up their vouchers somewhere, they'll make sure that like that those people can't, that the control group and the treatment group can't even be at the grocery stores like at the same time. Like there's just because they just are like super strict. They're really controlling their data though, and lots of times in the observational studies that there's not the same level of care. Yeah, exactly. And Alexander's kind of anticipating homework number 1. A lot of this is going to be coming up in homework number 1, to be honest. That's where it's coming up. Okay. So summarizing it, I don't want to give these answers away. So in summarizing them, but this was like SUTVA right here. There's SUTVA. There's no anticipation. No anticipation's there. SUTVA is there. That's the role that SUTVA is playing. That's the role that no anticipation is playing. You have both of them. You have parallel trends. Okay. So it's no anticipation and SUTVA are key for making diff and diff such a simple expression. And also making sure that you're not using already treated groups in general. That doesn't necessarily violate SUTVA. You could just be using bad controls, but we'll talk about it. All right, so there's lots of restrictions that are placed on diff and diff. No anticipation means you got to choose a baseline that is not treated. SUTVA means that your comparison group is never treated during the course of the calculations, and parallel trends means that your comparison group has a trend in expectation Y0 that is the same as the counterfactual. Only when you have no anticipation in SUTVA will diff and diff equal average treated on the treated plus parallel trends. That's all. A lot of people do not know that. It is only when you have these both that you get this convenient expression. And this is going to turn out to matter for two-way fixed effects. The last thing I want to just kind of summarize, diff and diff are not the same thing. We go back here. Diff and diff, 4 averages, 3 subtractions. ATT, one subtraction, 2 averages. It's just that the 2 averages are referring to a counterfactual. One of them is a counterfactual. All right? Now you heard Orley. We go back to what Orley said. Orley said, I'm not going to go back to it. Orley Ashenfelter said, he realized when he was talking to these bureaucrats, that they did not know what a regression was, and they glazed over. This actually kind of goes back to Jon Snow, to be honest. This actually goes back to Jon Snow. Jon Snow was also trying to communicate with people. And he knew that in order to convince people, he was going to have to use rhetoric, not just science. Rhetoric is the art of persuasion, I think, or something like that. And the rhetoric he used was beautiful maps, beautiful visuals, right? Lots of different kinds of evidence. And so Orley's approach was to say difference in differences. Why? Because he could write that down. He could write this down and they would understand it, right? So much of causal inference is about trying to figure out how can I communicate this to a normal person, right? So simple diff and diff equation will identify the ATT under parallel trends, and so will a particular OLS specification, and we saw it. This OLS specification right here, post-treat interaction, gave us a 0.0682359. 4 averages and 3 differences. 0.068239. So there is an equivalence. There is an equivalence between diff and diff and a specific regression specification. Not diff and diff and regression. It's a particular one. It's this one. It's the dummy variable for the treatment group, the dummy variable for the post, and the interaction. And that coefficient will equal 4 averages and 3 differences. So I want to show you this. A lot of people like using OLS. Why? Because here's what OLS is. That's OLS, one line. 4 averages and 3 differences. That's 4, 8, 9 to 10 lines. And I got no standard error. They didn't say anything on this. They said, Athey and Emben said, they said that Blundell's assumptions were too strong. Blundell had said you needed exogeneity for the and I got what you said, sorry. For OLS, for ordinary least squares two-stage for two-way fixed effects, Blundell said, okay, so Richard Blundell, he's at University College London. He's a well-known labor economist, and he was very active in the 90s about all this program evaluation stuff. It was really weird. When I was doing all this like first, second, third wave stuff, I was like doing all this research. Blundell's name was coming up all the time in the 90s about diff and diff, and he was like trying to get everybody to understand it. And he says he's running two-way fixed effects models. And he's saying what you need for two-way fixed effects to be unbiased is you need exogeneity. And exogeneity was this, that the error term was independent of the variables, the group term and the variable term. And so in a paper by Athey and Embens, I think it's their changes and changes paper. I can't remember. It's this, I think that's right. They say Blundell is right. You could assume exogeneity, but you don't need to. It's too strong. You can do it with less. And you know, well, what is the less? Parallel trends. Because you get parallel trends with exogeneity, but you get more. And you don't need all of it. Some of it's irrelevant. And so some of the things might not hold in your data, but you can do it. So what we're going to look at is just, you know, the fact that OLS will though, sorry, where? Here. So OLS, a particular OLS specification, specifically this one, post-dummy, treat-dummy interaction, coefficient on the interaction is 0.068239, 0.068239. It is equivalent to this. It's the same thing if you do it that way, right? So people like it. So people like using OLS because it's one line. And look what you get with OLS. You get this little nice guy, standard errors. You can build confidence intervals. You can do t-tests. You can get p-values. 4 averages and 3 differences. It's going to be a pain to do that kind of stuff. Okay. So you can calculate standard errors. You can put in more time periods. When you put in more time periods, you can get more power. Power will reduce the standard errors. So people liked it for that reason, but they also liked it for differential timing. They also liked it for continuous treatments. They also liked it because you could put in covariates. And these 3 things actually turn out to be a lot more complicated than what we're going to talk about, okay? Those are some more complicated, so we address them later. We address covariates tomorrow. We do differential timing after that, and then we end with continuous. All right, so Card and Kruger have this famous study estimating causal effect of minimum wages on employment. New Jersey raises its minimum wage April 92, between February and November. Neighboring Pennsylvania does not. Using diff and diff, they do not find a negative effect of the minimum wage on employment, right? Which for those that are from so like to non-economists, like this is kind of like, well, they just don't. I think a lot of non-economists might not be able to appreciate that is kind of harder for them to kind of take, because we teach in like our principles, our like intro classes, they call it Econ 101. We'll teach that like if you put a minimum wage in and it is binding, it will increase unemployment, it will reduce employment. It's actually though like very, very specific situations where it would even happen, but a lot of that hand waving is sort of brought away. So they do it, they don't find it. We'll look at it in a second, but listen to what Orly Ashenfelter said about the response to the paper. Oh, okay, hold on.
Long have to worry about dodging the alien.
Yeah.
That's it.
Gotta always change it back so you can hear. Oh, where are we still in it? Okay, let me do this.
There was low-lying fruit. The standards everybody in labor economics. I get an example I often give is when Card and Kruger did their paper on minimum wages. The thing about that paper that's so valuable is the fact that it was so well designed. Right? They went in the field before the actual law had been changed. But remember, it's just fast food chains, not including McDonald's in New Jersey. Mm-hmm. It doesn't cover very many people. And yet it had this influence, I think, because of the design.
Yeah.
And but most labor economists, now not others, but most labor economists, when the results came out, well, we can't find a very big effect, that didn't surprise anybody.
Oh, really? That was not surprising?
No, because most of the work that had been done before that was so poor.
Oh.
It was so poor that everybody knew that nobody had it. In fact, one of the reasons.
Okay, so that's Orly's opinion. Orly Ashenfelter is David Card's advisor. David Card won the Nobel Prize 2 years ago. All right. And this is a famous paper. Orly said no labor economists were surprised, right? That they said, because we don't know anything about the labor. We don't know anything about the minimum wage because all the papers had been so bad. But James Buchanan, a Nobel laureate who was not a labor economist, and he was not an empiricist either. There's in some of the other lectures I've given on this, I go into just a ridiculous amount of detail of the history. And I recently did this presentation and it was kind of clear that nobody in the room cared about this like I do. But anyway, James Buchanan wrote in the Wall Street Journal that Card and Kruger were undermining the credibility of economics by publishing the paper, and that if anybody believed them, they were a bevy of camp-following whores. 3 minutes, okay? I want you to listen to Card talk about the hostility that he experienced from this paper.
Fire.
Now remember, this is David Card. He's the author of the minimum wage paper with Alan Kruger, who passed away. And Orly just said that this paper was not controversial to labor economists, but we did see that James Buchanan said a horrible slur if you believed it. Wrote it in the Wall Street Journal. Can you imagine publishing a paper? Nobel Prize winner basically says if anybody believes your paper, that they're that word. Is that crazy? I can't even imagine. So listen to what else happens. So again, Orly said nobody's surprised, but listen.
And was there hostility that you guys experienced? I mean, if you only read Buchanan's very colorful op-ed, you would think you guys were getting bricks thrown through your window or something.
Pretty close to that, yeah.
It really was? Can you tell me a little bit about that?
It was pretty bad, yeah. I mean, there was Yeah, it was pretty awkward, it was very,
Like, give me an anecdote. You don't have to say a name, but like,
so for whatever reason, the American Enterprise Institute decided they wanted to have a forum on minimum wages. And so they had Finus Welch and Kevin Murphy come on the other side, and Alan Kruger and I come. And I remember
this is like late 90s, or is this
no,
right
this is
after,
like
right after the paper?
95, 94, 95.
Okay, so it's like the paper's like out.
Yeah, just around the time the paper's been out. And,
Yeah.
And we go down there and on the train, and they have this big forum, and there was a labor economist, an old-time Australian labor economist who's still active, named Bob Gregory. And Bob is a very interesting person. You know, like if you wanted to have your archetypical, what would happen if you crossed an Australian with a labor economist? You'd get this guy. Really, but a really entertaining, observant person. You know, and so Bob is there in the background, and so during the course of this discussion, it gets to be pretty heated. Finus Welch really got pissed off about this whole thing. Wages. He just thought that we were. I think, for at least for a long time, thought that we'd faked the data or made something up.
But so why is he doing? I mean, Orley said amongst labor economists, it was not terribly controversial, but he said because the kinds of papers that have been being written were not so great. And so labor economists were like, you know, nobody knows.
I think Orley might be there. I think among, you know, there were some labor economists who weren't so negative, but there was an ILR symposium on our work. That had a review of our book, Myth and Measurement, and it has a paper by Finus, and you could go read that. It's pretty scathingly negative. Anyway, during the course of this,
you're like 40. This is like, because you said 50s, so it's like nice. You're like in your early 40s or like late 30s.
Yeah.
What did it feel? I mean, these guys were probably not just contemporaries. I mean, you probably looked up some of these guys, right? I mean, they were
the leader. Like Finus was considered a leader of the field. He basically, his company found its data.
Yeah. So, I mean, what did it feel like to you and Dr. Kruger having so much kind of spiteful negativity? That wasn't very common. That kind of like, you didn't have these kinds of throwdown matches, or what? I mean, you always hear.
Not that I knew of in labor. That's the first time I'd ever heard of it. So in the course of this conference, a woman economist gets up and she was kind of more conservative side and said, "Well, I just don't understand how you can."
Okay, so probably worth noting that a lot of these guys are Chicago trained people, and Chicago seminars at the time were notoriously, you know, combative. So that's something to kind of think about. But here, let me look at this one.
Very rude. That's very different.
So what is this about? Okay, so then listen to what Sherwin Rosen says. Actually, I'm going to skip to 116, 117. So watch this.
Disagreeing with a paper. So taking it personal. Wow. How did Dr. Kruger take it? Were y'all pretty similar?
Pretty badly, I think, too. Yeah. I mean, it wasn't a great period of our lives.
Wow.
Actually, he was in the Department of Labor when the minimum wage book came out. And then in 1996, I guess there was a proposal to raise the minimum wage under Clinton, and he was pretty highly involved with that.
Yeah.
And one of the congressmen from New Jersey basically like led some investigation against him because the Republicans had gained control of the House. And they had a huge investigation of him and went through all his papers and financing and everything, you know, like his personal finances. I didn't know you could do that in the United States.
Oh my God.
Luckily for Alan, his father was an accountant, and Alan had the cleanest accounts in the entire
country. Oh my gosh, that is so infuriating to even hear.
It was really scary. I mean, it was like you realize that, and you know, this kind of thing is happening all the time nowadays.
Right. Right.
And see, but
so that's crazy, right? Like you think about how somebody doesn't like your paper. And then you think about how, well, at least he's not getting me audited. You know, this was just so intense, you know, so intense. And these guys had to like get up every day and go into work with people basically calling them data fabricators and frauds. And Alan Kruger is a public servant, you know, working in the Department of Labor in the Clinton administration, and a legislator from New Jersey gets him audited. I mean, it's just kind of like, I can't even believe it. Over a diff and diff. Over a diff and diff. I mean, like, I'm not trying to like overstate it, but it's like, this is now like the third time we've talked about where the diff and diff is like being used in pretty high stakes, controversial, policy relevant work. It was like Semmelweis. Nobody believe, all these people are dying. Semmelweis is completely, you know, vilified after it's over, ends up dying in a mental hospital. Jon Snow is canceled, basically. Nobody believes him either. Card and Kruger. Card had just won the John Bates Clark Award, which is the big award in econ for young people. But you know, he's persona non grata. Like, you know, he's like viewed as, or like some people are saying about that. So he says, I've subsequently stayed away from the minimum wage literature for a number of reasons. His first job out of Princeton was at the University of Chicago. And that's where Sherwin Rosen was. I don't know if Finus Welch was there. Kevin Murphy was, though. Yeah, it's right. I'm going to comment on that statement. I've subsequently stayed away from the minimum wage literature for a number of reasons. It cost me a lot of friends, people that I had known for many years. Some of the ones I met at my first job at the University of Chicago. He's probably talking about Finus. He's probably talking about Kevin. He's probably talking about Sherwin. Became very angry or disappointed. They thought that in publishing it, we were being traitors to the cause of economics as a whole. It's interesting, right? The diff and diff is really neutral. Yeah. Alexander. It is brutal. It can be brutal. It's like people have different opinions about it. I've heard people say, you know, like, you know what's far more brutal than a seminar in economics? The journals, the referees, and those are anonymous. And so a lot of people feel like, you know, let me have it in the seminar so I can fix it and get it ready for the journal. And so, and then, you know, so a lot of people are like, you know, if it's going to be this, but that doesn't mean you have to be a jerk in the seminars. So anyway, I like telling all that. I like it. I hope y'all don't mind. I love the color and the stories a lot. So anyway, this is the correctly specified OLS regression. Oh yeah, and I was going to say, Sabin, I think it really showcases how you said serious is the impact of the work researchers essentially do. Yeah. You know, somebody said something to me once, my chair. He said, the really, really good papers and the really, really bad papers take the exact same amount of time to write and publish. Well, actually, to do. So you might as well work on the good ones, the stuff that really matters to you anyway, stuff that really matters to you. You might as well work on it, because when you work on stuff that really is not a big deal to you, it's just kind of, it's like, you know, like trivial to you is trivial. You know, I'm not saying trivial to other people. That's not what I'm saying, but like trivial to you, it takes the same amount of time, if not longer. It takes me way longer to work on stuff I don't care about than to work on the stuff that I'm passionate about. So, correctly specified OLS regression is an interaction with time and group fixed effects, and here's why. Here's why. We're going to get into that, Renz. That's next week. That's the two-way fixed effects stuff. All right, so look, here is a regression equation. And we're going to show that this regression equation, that right there in the regression equation is the same as 4 averages and 3 differences. We're going to show why exactly it is. It's completely equal. Here's why. All right. So for the, oh, I'm sorry, Winchin. I saw you ask that. So what do you make? Well, you could, I'm not positive. I mean, if you believe Sutva, that, that's a good question. When we look at the triple diff, maybe that's sort of similar. That could be, yeah. Triple diff could easily be something like that. You might be talking a little bit about the spatial RD design, but when we look at triple diff, let's think about your question in that way. So let's take this regression and let's then take the information from this regression, okay, and turn it into the 4 averages and the 3 differences. All right. So for instance, all right. So I want to know Pennsylvania in the pre, right? So the thing is, each of these estimated coefficients, like when you actually estimate them, okay, you're going to get this. And then that's going to go away, right? And you're going to then say, add all this stuff together, multiply like this, take this coefficient, add in this coefficient plus this dummy, 0, 1, plus this coefficient time that dummy, plus this coefficient times that dummy, right? And when you do it, you get average outcomes. You literally get an average according to whether it's Pennsylvania or New Jersey in the pre or the post, right? All we got to do is approach it. Like it is switches. Okay. So we're just going to approach it like it's a switch. Oh, shoot. Okay. So here, I want to know Pennsylvania in the pre. What do I do? All right. Well, Pennsylvania in the pre, that's a New Jersey dummy. So that'll be equal to 0. That is a post dummy. So that will be equal to 0. And that's a 0 times a 0. So that'll be equal to a 0. And so the Pennsylvania in the pre, if I want to know average employment of Pennsylvania in the pre, I just look at that. I look at the constant. And the constant tells me average employment for Pennsylvania in the pre right there. I just look, it'll be a number. Like literally right here. That's homicides. That's the number of homicides, log homicides for my control group in the pre-period. So I could go like DI exponential 1.251846, 3.49 per 100,000 or something like that. Okay. So that's telling you, the constant is telling you the control group pre, because that's a 1, that's a 0, that's a 0, that's a 0. All right. What if I want to know Pennsylvania in the post? Well, that is still a 0. So that goes away. It's the post period though. So now that's a 1. And a 0 times a 1 is a 0. So that gets away. So if you want to know Pennsylvania in the post, you sum. Oh, shoot. You sum the coefficients. And that'll tell you average employment in the post period. So for me, that would be, so that was alpha plus the coefficient on the post dummy. So that would be alpha plus the coefficient here. So it would be 1.251846 minus 0.055. So that would mean if you wanted to know the average average homicides in the post period, it's going to be actually 1.2. 0.055. So it'd be like 1.19. Okay. What about New Jersey in the pre? Right? New Jersey in the pre. Well, that's going to be a 1. So that's going to be there. But it's the pre. So that's a 0. And 1 times a 0 is a 0. So if I want to know the amount of employment of New Jersey in the pre, alpha plus gamma. That'll tell you average employment in New Jersey in the pre, which would go right there. And then if I want to know New Jersey in the post, I go alpha plus, that's a 1, that's a 1, and that's a 1. Then you sum all 4. So that would be like, for us, that would be like, if I want to know for the group, for my treatment group, the average homicides in the post period, I would go this plus this plus this plus that. That'll tell me average log homicides in the post period. All right. So now I've got coefficient expressions, all right, of those averages, of those average outcomes. New Jersey in the post, and watch what happens. So New Jersey in the post minus New Jersey in the pre. Boom. Immediately knocks it out. You see that alpha plus gamma minus alpha plus gamma goes away. Pennsylvania post, Pennsylvania pre. Goes away. New Jersey post minus New Jersey pre is this minus PA post PS pre. So goes away. It leaves you with delta. That right there, same thing. It's the same thing, which is why four averages and 3 differences gave us the same number, because it's the same thing. So long as that's the specification. No covariates. No covariates. Okay. Here's that picture from Angus. So here we've got New Jersey in the pre, New Jersey in the post, rows. So that's a Y0, Y1. Pennsylvania in the pre, Pennsylvania in the post. That's a declining Y0. And so what we're saying is that under parallel trends, oops. If what happened in the control group is what would have happened in the treatment group, OLS will be an unbiased effect of the treatment effect, because that's Y1 and that's Y0. But if that's not true, okay? If that's not true, and that's the counterfactual trend, then that's the ATT, and that's just diff and diff. Remember, they don't have to be the same thing. No. Wang, think back to this equation. There's diff and diff, which is equal to that OLS specification. Add the 0 in with the switching equation. What do you need in order to get the average treated on the treated? That is all you need. Stating your heterogeneity does not matter. Doesn't matter. This is what you need. You need the average outcome of Y0 trending over time to be the same for the two groups. That's all you need. This specification is fine. This is the specification. What you need is this. Okay? If you start putting in all these fixed effects, it changes it. And you're going to need probably something else in order to get that ATT. Putting in the panel fixed effects is going to be equivalent to doing it. But like, I mean, you know, you still are going to, you just got to be careful. So, inference, though. You know, when you're dealing with clustered data, there's a crucial concept, the difference between correlated observations and correlated errors. They seem similar, but they're not exactly the same thing. So correlated observations occur when the observed variables are correlated within a cluster. For instance, incomes within a specific region might be positively correlated. Correlated observations don't necessarily violate these OLS assumptions about the spherical disturbances, at least for the unbiasedness, it doesn't matter, but for the standard errors. Clustered errors occur within where unobserved errors, which you cannot observe, are correlated within a cluster. So this violates the assumption of IID, identical and independently distributed errors, leading to possibly biased standard errors and higher over rejection rates. So failing to account for clustered errors was something that that was really like one of the only econometrics papers that was published on this. It was by Bertrand, Marianne Bertrand, Esther Duflo, and Sendel Mullinthan have a quarterly Journal of Economics article, 2004, titled "Should We Believe Diff and Diff Estimates?" And basically what they found was that everybody had been just using the standard heteroscedastic robust standard errors. And what they showed through a lot of simulations was that if you had any kind of serial correlation in those errors, which would violate that assumption that's inside heteroscedastic robust standard errors, then you'd end up with standard errors that were too small. The sampling variance of the estimator was sort of larger than you were finding. And so they proposed 3 different solutions. One of them is kind of an odd solution. I used to teach it. I'm not going to teach it anymore because it's totally weird. Well, it's the correlation. It's within a cluster. So it's within the it's over time that we're talking about. Correlated. You still need independence across the clusters. You still need it across. There is multi-way clustering stuff. So, I actually haven't seen anybody use that with diff and diff. Now that I'm just thinking out loud. But I'm talking about, yeah. So they do the bootstrap, Wing Ching. They do the bootstrap. So clustering standard errors, they propose 2 solutions. One of them is to bootstrap and treat the state as the unit that's going to be bootstrapped. And then the other is to just sort of allow for arbitrary serial correlation within the cluster. Those are the 2 that work well. Most people do the cluster, robust, because why? Because in Stata, that's the command. To get doing the bootstrap standard errors is in like other steps. So, and in the old days, people would have had to program it to actually do the looping on it. And so, to do that, to program up a bootstrap is not easy. There is canned now packages, but I'm not positive if that was available in 04. So it's not easy to do. And so people typically people typically, oh shoot, we went 8 minutes over. All right, so let's take a break. Take a 15-minute break. I'm sorry. We'll come back in 15 minutes. 24 minutes on the hour. We'll come right back. Yeah. So some people have to leave. So it takes a while for Zoom to compile from the cloud and then move it to the it takes a lot longer to go from the cloud to the computer than compiling on the computer, but I've started compiling on the cloud because it's less error prone. My worst nightmare is somehow something like I screw it up. So 3 hours is usually what it takes. And then I got to do an hour up. So sometimes it's like 9 or 10 o'clock before I can post it. That's what I'll be shooting for before bedtime. And then I'll send out the password. Dishab said, here, let's look at that. If the treated and untreated units have the similar, so does this, no. It's all about potential outcomes. It's all about potential outcomes. Okay, it's not about whether the groups are similar or not similar. That's irrelevant. It's not about covariance. SUTVA means when a unit is treated is when its outcome is equal to Y1. And when it is not treated, its outcome is equal to Y0. SUTVA violations means when a neighbor is treated, an untreated unit gets treated. So it's like an externality concept. Although, it's like externalities are more specific than that. So it's a little bit, they just say no interference. No interference between the units in terms of the treatment status. All right, so let's look at these parallel trends violations. We got 2.5 hours. All right, we got 2.5 hours. You can think of it as spillovers. Just think about it. Think about it as spillovers. But keep doing this though. This is all I ask, is call it whatever you want, but just keep this. Keep that in your head. I am treated. My outcome is Y1 if I am treated right now. My outcome is Y0 if I am not treated right now. My potential outcome, my potential outcome is based on my treatment right now, not yours and not the future. Does that make sense? That's how you want to think about it. So this is the switching equation. I don't like to call it SUTVA because SUTVA is, but like Pedro Santana calls this SUTVA. So it just basically, because why? Because basically what SUTVA means is like, I am treated or I am not treated. If I am treated, my realized outcome is Y1. If my roommate gets vaccinated, it might affect my own potential outcome in a world where I don't get vaccinated, right? So it's like, you're needing it to be that your potential outcome is stable. It's not changing as a result of other people's treatment assignment. And, spillover is a great word for it. No interference is another. Heck, externalities is one that most of us understand in econ, but in stats, they're not a behavioral science and statistics, so they just say no interference. All right, so now what we're going to do is we're going to look at parallel trends violations. This is a metaphor that I want you to be having in your mind, okay? Because this workshop is about diff and diff, but this workshop is also about convincing people. Because it's like, Ignaz Semmelweis did not convince anyone. Jon Snow did not convince anyone. David Card and Alan Kruger did convince people, but they did not convince the critics, the skeptics. So you have to think about like the difference in differences and what are all the pieces that go together to make a diff and diff hard to ignore. That's the deal. What is it? So these top 5 papers, these diff and diffs that are in these like leading journals, they're not merely like I did a diff and diff. It's like they did a great job at building a great body of evidence, okay, inside a diff and diff. So I want you to think about it like this. You are a prosecuting attorney who is trying to argue that the defendant is guilty. And you have an opponent. That opponent is the defense attorney. And you've got to convince a jury and the judge of guilt. The diff and diff, okay? The diff and diff is you asserting that they're guilty, okay? The diff and diff is not the evidence. The diff and diff is you saying your client is guilty. Evidence is something else. The evidence is the smoking gun, the fingerprints on the gun, eyewitnesses that saw you shoot him, footprints in the mud outside the house. That's evidence that supports the claim. Your diff and diff is not evidence. Your diff and diff may not be true. Your diff and diff is true when? If parallel trends is true. So you have to provide evidence for parallel trends, not for the diff and diff. You have to find evidence for the parallel trends assumption, holding. That's your job. You have to present your claim, and then you have to back it up. Okay? And if your claim is supported by weak evidence, then of course the jury should find the defendant not guilty. Okay? It would be borderline corruption if they did not conclude that. Okay? So causal inference is about warranted beliefs. This is kind of getting philosophical. It's about, should I believe this causal claim? It's about beliefs. And are the beliefs rational? Your diff and diff results, okay? Your diff and diff results is our number, but it is not the same thing as the smoking gun. Exactly, Sabin. It's trivial. It's trivial to calculate 4 averages and 3 differences, right? Like Orly said, any idiot can do that. It's a 3rd grader, knows how to do subtraction. And if they know the numbers, they can do subtractions. There's only 3 of them, right? That's diff and diff. This is only true, watch. That does not change the diff and diff. That changes the ATT. But the diff and diff is always going to give you 29.99, right? And so the reason why this suddenly is not the right answer is because parallel trends didn't hold. Because the change in Y0 for group 1 was 131, but the change in Y0 for group 2, it stayed the same. It was 5.52. It's just that 5.52 was no longer a proxy for the change in Y0 over here. Okay, so we've got to figure out what are standard types of evidence. This is like, and what I'm doing right now is I'm basically saying this is the standard evidence that all your papers probably are going to need to comport to. That takes for granted that you have the right data. And even then you have to get lucky. Even then you have to get lucky. Like, so this paper right here of mine, I only have 1 top 5. It got rejected at the AER. It's not even listed. It got oh, there it is. Got rejected at the JPE. That's 2. I wonder what that is. Manisha. It got rejected at QJ. At JPE, Journal of Political Economy, it got, that was in May 2015. AER was 2014. Then we did JPE, rejected. We got 1. Wait, did we do that? Maybe we did QJE first. Let's see. QJE went first, 2013. All rejects. Katz's rejection letter. Let's see what he says. I haven't looked at this in years. Dear Manisha, I attached 4 knowledgeable referees on your submission with Scott. Referees I've admire about your thing. You provide pretty convincing evidence that the court ruling in 03 led to an expansion, indoor prostitution in Rhode Island. suggestive evidence of price reductions and on reductions in reported rate. It's well crafted. Nevertheless, as you can surmise from the attached reports, referees have significant reservations concerning the plausibility. And he says, just go away. They just didn't believe it. So we sent it to the AER. And I don't know where the letter from maybe that was it. Hillary Hoynes. So she says, heard from 3, makes an important contribution. First quasi-experimental analysis of a decriminalization policy. You make excellent use of multiple sources of data to shed light not only on crime and public health, but what's happening in the market for sex work. Fortunately, none of these referees think that the paper is a good match for the AR. I think there are a couple issues. First, despite your presenting sent along with basic graphs and diff and diff, the analysis comes down to a small number of annual data points for a very small state. While I think you do the best you can, referees were not sufficiently convinced. Referees would like to more on how the market changes. Market is, can't go for it. Look what they say. Might try the AEJs. They're all saying go away. Go away from the top 5. JPE, though, we got lucky. One referee at the JPE said revise and resubmit. 2 said reject. The editor said reject. And we were finally about to give up. And, but then something happened. I saw a YouTube video, and this YouTube video was by Restud, Review of Economic Studies, and it had all these people that did applied micro. Usually, for those who don't know, Restud, Review of Economic Studies, is arguably the 5th of the top 5, and we didn't think that we weren't going to send it to Econometrica, and so it historically did what's called theory, structural, and experiments. But there was this like YouTube video where they were doing this advertisement, and it was clear that Review of Economic Studies was now accepting applied papers. Here we go. February 2016, I will never forget it. 3 reports. Reactions are mixed. Referee 1 recommends R&R. Referee 3, R&R. Referee 2, reject. Editor gives his R&R. It is a major revision. It goes through, oh my gosh, how long is it? What does it go through? Second, third, goes through 3 more rounds. So you'll still have a hard time publishing these papers, you still have a hard time with them, but they, were not rejecting based on the diff and diff. But it was kind of interesting. They were basically rejecting based off skepticism. Getting somebody to believe something that everybody says is not true, it's an uphill fight. That's why everybody rejected Ignaz Semmelweis. It was contradicting major orthodoxy. John Snow was going up against orthodoxy. Card and Kruger going up against orthodoxy. To do those, to go up against orthodoxy, you have to have strong evidence. Okay, so that's what this is about. Evidence versus the main result. And ours was a diff and diff. It was synthetic control, and it was diff and diff in our paper. So your diff and diff results, all right, so here's what I consider to be evidence. Byte, falsifications, mechanisms, and event studies. We're going to mix the parallel trends violations with this concept of evidence before we get into the advanced estimators, because everything else, no matter how fancy the estimators get, it never stops being true this. All of them will want to have byte, falsifications, mechanisms, event study graphs. Okay? It's just that the models will change. So here's 3 classic parallel trends violations. The first is what's called compositional changes with repeated cross sections. It is not a well-known problem. One of the risks of working with a repeated cross section is that the composition of the sample may have changed between the pre and post period in one of the groups. And it might be that it's correlated in a way that would violate parallel trends. I'm going to give you an example. Hong, econometrician. I don't think he's an econometrician. He's an IO. It's like an IO guy from Stanford, studies platforms and things like that. And he has this really cool paper. This was his job market paper. Uses repeated cross-sectional data. He had the idea for this. He was the first one. He's the first one that thought of this repeated cross-section problem. And he basically says, you know, you can get this problem if you're working with a repeated cross-section that you would not get with a panel. A panel data set observes the same firms over time or the same people over time, but repeated cross-sections work with a sample, works with a sample of people. If it works with a sample of people, you are not following the same people over time. Okay. So he's going to use data from this interesting federal data set called the CEX, Consumer Expenditure Survey. And you can match in the Consumer Expenditure Survey, you can match to other surveys. Like there's a survey that had data on whether or not people were on the internet for a random sample of households. Now, he was studying, it used to be a big deal. He was studying this peer-to-peer software called Napster that came out in 1999. And when Napster came out, I mean, it's kind of fascinating. The time series just shows the effect, like it just fell. This is spending on, yes, different samples. It's like you know, the census, current population survey, you know, you basically randomly sample 10% of the sample or you population, or you like randomly sample 1%. The GSS, a panel would be like panel survey income dynamics or the National Longitudinal Survey of Youth. That's following the same kids over time, right? So that's a panel. Or you can have a panel of firms, or you can have a panel of police jurisdictions. You know, it's just that are you following the same units? You could have the state be the panel, you know, but it's usually going to be that the state is a panel if it's like the state is observing not a sample. Like data on crime will be the universe of crime. Okay. So that'll usually be like a panel. So he wants to know, you know, is Napster causing the spending on music to go down? And he's going to do it in this kind of interesting way. This is really motivates his econometric estimator. I'm not going to teach this econometric estimator. I'm going to teach more about, I'm just going to show you a way that you could go about kind of evaluating if you think you have the problem. And I'm going to point you to an updated version of the paper. But he's going to treat 1999 as the natural experiment. He's going to compare internet users. He does not know who is on Napster. So he's just going to compare internet users to non-internet users, right? So here, I'm going to do some drawing. So this right here is non-user groups. This is the non-user group. 1999 is going to be the treatment. And this is the internet group. And this is their spending. So like right here, 1996, the internet users are spending 27 million. The non-internet users are spending 12. In this year, the internet users are spending 17. And the non-internet users are spending 7. So if you say that drop is what should have, if that drop here, right? If that drop is what would have happened, okay? Although it would technically be, you know, I mean, it actually is different than that. So it's like 1999 is this would be like 1998. Okay. So that'd be like to baseline. If that's what would have happened, then every single year is a treatment effect. And so you would say that like, by in 2001, Napster caused, what would it be, like 22 minus 16 is like, maybe like 5, maybe it's around 5. Yeah, it's 5. So it's like caused the average music expenditure in $1990 to fall by $5 per person. So, that could be, like that's in the millions. But pretty clever because he doesn't really have geographic. So he uses a group, he uses like a person. And he basically, parallel trends is just saying for this group. Yeah, if you look back at the parallel trends assumption, it's like for this group over time. Doesn't say geography. It says for this group. Okay. But look at what's going on. Over time, more people are getting on the internet, and it's probably not random. So like 8% are on the internet in 96, and it's like 35%. Well, what kind of people are getting on the internet? Well, the internet users are getting older. Every year they're going up older. And I should have seen like you know what? It's the first time I've noticed. I need to get the 2000, 2001, 2002. Hold on. Can't believe I've never looked at that. Huh. Where the heck did I get that picture from? Must have got it from so weird. Well, anyway, so the non-internet users stay about the same. Internet users, 40, 42, 44, 44. High school graduation, 18, 17, 21, 22. They're getting more high school graduates, some college, 37, 35, 34, 36. Do we have any income data? Oh, yeah. 52, 51, 49, 47. Incomes are going down. Incomes are going down. Yeah, this is much better. I'm gonna have to put this in. So, it's so weird. I literally do not know. I must have had a working paper. So anyway, look, a couple of things. They're getting older and they're getting poorer. So this is selecting on poor people that are older. Poorer people that are older buy less music. Y zeros are changing. On their own, they're changing in a way that will, like even if Napster hadn't been there, the Y zeros would have changed anyway. See what I'm saying? So it's like what you need is this like stationarity assumption that you're not getting. It's okay if you get different. I mean, you're getting different people, but they cannot be systematically different with respect to their Y zeros because it's the Y zeros that you're needing for that parallel trends assumption. So it's a surprisingly underappreciated. Well, that was no. See, Naya, that was his paper. His paper is all about, like, look at what his paper is. Paper measures the effect of Napster on record sales. I use diff and diff. Because of potential compositional changes in internet users, I examine identifying assumptions for diff and diff under compositional changes and develop a test for identifying restrictions. So he To address potential bias, I extend diff and diff matching estimators to the case of two variant propensity scores. I find evidence suggesting. So his paper was like his paper said, this problem is here and I'm going to use matching to fix it. I'm going to match on observables. I'm going to have it be a kind of like ensuring that I'm working with the same groups of people on observables over time. So, but it's a little bit different than what we were doing. So but that's what he's doing. Yeah, it was. So Pedro Santana is a guy that, he's the hardest working guy in show business. He's got just never ending energy. He has an update to it with different compositional changes. And I haven't read it yet. I'm in the process of doing a major retooling, and so that I can teach a new workshop on diff and diff that's a little bit more advanced. But I'll be kind of bringing in a lot of these more advanced estimators in that. But that's a paper you could look at, and I believe it's in here. Well, if it's not, I'll find it. There it is. Paper studies diff and diff setups with repeated cross-section on potential compositional changes. We begin our now. Okay, yeah, he's doing a bunch of other stuff. His might be at, yeah, so he's got a different kind of estimator. Anyway, it's in archive. Is it a Journal of Econometrics though? Nora, we're going to talk about covariates tomorrow. We're going to talk about covariates tomorrow. That's Pedro Santana. That's a different person. All right. Well, I'll do this later. So if you're going to do this, you're going to be using, right, Santana. I always misspell it. Replace the outcome with your time varying. All right. So severely underappreciated problem. One of the ways that you could test for it, though, is to find time varying covariates, put them in your diff and diff model, and that these are covariates that are highly predictive of Y0. Things like age, spending on for the Napster thing, it would be like spending on music in a world where Napster didn't exist. Then what are ordinarily the things that are determining Y0? Put those covariates on the left-hand side, run your regression. Though the treatment should not have, your treatment cannot change your age, right? Cannot change your income. Napster can't make you wealthier. Napster, though, could be getting on. Yeah. So, all right. So that's one thing to do. I would just recommend, if you are working with a repeated cross section, I recommend you read these papers. All right. And then do your own test as to whether or not you think you have the problem in the first place by just checking for, on the left-hand side, time varying covariates in your diff and diff model, time variant covariates that are highly predictive of Y0 though, and see if your treatment is correlated with consequential changes in those outcomes, those covariates. All right, so here's the event study. I said that was a part of the wave 2. Can't directly verify parallel trends. So for a long time, researchers would focus on the pre-trends, which was in a previous time just called Ashenfelter's dip. So if the just prior to, yes, exactly, Yinju, it's only for the repeated cross sections, because for the panel data, it's always the same units. So, you can't be getting compositional changes. With an imbalanced panel maybe, but if you balance the panel, then it won't matter. So they would kind of work on the tradition of the diff and diff would sort of look at the pre-trends. And at some point, the pre-trends just sort of got smacked on top of parallel trends. And so they would just say, well, if you've got parallel trends, if you've got parallel pre-trends, maybe you have parallel trends. You still have to worry about other policy changes, like there might be a policy change that happens at the same time as the treatment, but this would be something people did. So sorry, I'm yawning. So if you have two groups, you can plot the raw data when there's only two groups. If you don't have any information about past periods, Anna, then it's going to be, you don't need it. Okay, that's a great question. That's a great question. Let's go back to the start. Diff and diff only needs two periods. Pre and post. Pre must be untreated. Control group must be untreated. All you need with a diff and diff to identify the ATT, 4 periods, and you need parallel trends. Problem is, parallel trends is not testable. It's not observable. You will never know what that Y0 was. You need, though, the counterfactual trend to be equal to the observed trend. Purpose of the event study is to try to provide some evidence that parallel trends probably holds. And if you believe me that evidence is going to include the event study, then it severely weakens the study if you do not have an event study. Oh, that's a good point. Yeah, Alexander would probably, that's a great. Of course, if you have randomization, you don't even need to do the diff and diff. You can just do the comparison. If I guess it's like you would, but yes, you'd have to have strong evidence for randomization. That Alexander's is very helpful, Alexander. So here we got what you could do is you could plot the raw data, right? Plot the raw data. And this is like, and a lot of people really like this. They want to see the raw data plotted. And so if you have the raw data plotted, okay, what you're looking for is the trends to be similar, not the levels, but the trends. Although Kevin Lang has a paper with other, I think they're Lang and Lang have a paper about when these levels are different. It is useful to try to figure out, why. Because if they're two different, people might say that they don't believe parallel trends will hold. But I mean, technically, the event study, it does not depend on them being the levels being the same. So here's what you're going to be doing. Is you're not going to be doing this usually, although people do like it. You're going to want to also run a dynamic regression. It depends on your parameter, Renz. It depends on what your question is. If you have a question that is basically, I want to know the average treated on the treated for this group of time, then you have to pick the periods. It's all driven by what your parameter is. So there's nothing wrong with putting it in. It just will be that will be what your, that will be your parameter. And under parallel trends, you will be estimating it with diff and diff. An event study, I think Alexander said this earlier, what the event study does, though, is allows you to kind of get those ATTs at multiple time periods. Okay. So here is the regression specification for a event study. Let's take a 15-minute break, though, because I know that I made us go over. I kind of want to get us back on track. So let's take another 15-minute break. Just kind of rest because it's long, and we'll be right back. Okay. Okay. So this is the event study. We're dive right in. Okay. So this is the event study or standard regression. When you have two groups, We're still in a world. Basics of diff and diff day one is all about two groups, treatment group, control group. We're not doing multiple time periods. This is going to give you unbiased estimates of the average treatment on the treated, because what we will show is that this coefficient, here's the deal. This is the outcome, constant, post dummy, calendar, or sorry, this is calendar dummies. Okay, I'm not very good at using the I operator. I can always forget how to do it. So I just put in here dummies. No, I do it right here. Yeah, but I should have done it right here too. Anyway, so that's a series of year dummies. Okay, except for the year prior to the treatment. That's your treatment group dummy. You're going to put those in by themselves, and then you will interact the treatment dummy with every single calendar year or calendar time period dummy except for baseline. And then because at baseline, every single one of these coefficients will be a diff and diff calculation relative to that baseline. So you will need parallel trends from that baseline. Whatever you choose as your baseline will always choose your parallel trends assumption. If you look back here, we chose pre, right? We only had 2 periods, but it's always holds. We have our diff and diff. We choose pre as the baseline. Pre is where the parallel trend starts. So whatever you choose in event studies, whatever you choose in event study to be your T minus what your dropped period, okay, it needs to be a period that is untreated. So it's got to be baseline before treatment. And that's the main thing. It cannot be treated. And we'll see why tomorrow. And then that will determine where your parallel trends assumption starts. It'll start from the omitted period. And every single one of the coefficients on every interaction, both post and pre, will equal a difference in differences, 4 averages, 3 subtractions relative to that baseline. It'll look like this, right? So you'll do, oh, I wish I'd have done it. Well, shoot. I'll do it in a second. I have it in a simulation, but basically all of these will be diff and diffs, 2 by 2. There'll be 4 averages and 3 subtractions, and they'll hold under parallel trends. They'll hold under parallel trends. So under parallel trends, this coefficient will identify the average treated on the treated for that period. Under no anticipation, there is no treatment in the pre-treatment period, so it should be a 0 if parallel trends holds for that period. For this period, if parallel trends holds and no anticipation holds for that baseline, then this will equal the average treatment on the treated for that period. Okay? So all you're doing in a simple 2 by 2 is just interacting the treatment dummy with your calendar year dummies. Okay? That's all you're doing. What you then do is you plot your coefficients and your 95% confidence intervals on what? On this and that. You don't care about this stuff. You don't care about this. You're going to take a single plot. I'm going to show you how to make it. You do a single plot of all of those and all of those. Under no anticipation in SUTVA and parallel pre-trends, mechanically, all right? You have no anticipation and SUTVA, and you have parallel pre-trends, then mechanically those are all 0. That does not guarantee the same thing about the post trends, right? Just because these are 0 doesn't mean that parallel trends holds over here. But see, with no anticipation and SUTVA, you at least are going to be able to evaluate parallel pre-trends. There's still some specification and power issues that John Roth has written about. I skip it for this, but I probably do need to have an advanced class where I discuss this. He does a workshop. It's the reason why I skip it. He does a workshop for me and he teaches it. So if you go over here, you can find his advanced diff and diff, and he goes through violations of this violations thing, and he'll talk about he'll talk about the testing for violations of the conditional parallel trends. So I don't like to teach it. So, but under NA and SUTVA and parallel trends, post trends, then this is an average treated on the treated for that period. Whereas before, when you had that one dummy, it was the average treated on the treated for all the periods. Like the ATT here was for average. But if you could do an event study, it would be basically that. You'd be plotting each of those numbers. Or no, sorry, you'd be plotting these differences. That's what you'd be plotting. All right. So the normal diff and diff coefficient equals the ATT plus the parallel trends. It was still post-treatment. Put it aside, diff and diff equations. Always identify the sum of these terms if it is a true diff and diff, meaning no anticipation and SUTVA, because that's no anticipation and that's SUTVA. Pre-treatment diff and diff coefficient, same thing. If you're calculating the T-2 coefficient, it is basically this. It is Y1 in the T-2 minus Y0 in the T-2. Well, it's not treated at T-2, so that's a 0. Okay? Leaving only this. But look at what's different. This is counterfactual. For the normal diff and diff coefficient, you do not know what Y0 would have been for the treatment group K in the post period because it was treated. Now look. All right. What do you have? You have pre-treatment T-2, you have Y0. Just now I'm looking at something. Yeah, so this is, I wonder if I did that right. ATT. I didn't add in a Y1. I wonder if that's right. So how would I get that? Oh. Oh, that should just be Y0. I need to make a change on this. Let me make a note to myself. Some of you might notice what I did wrong. Pre-treatment diff coefficient. This is page 96. You know what? We'll redo it for homework. Number 3. I'll show you where this came from. That's what it'll be. So for number 3, I'll redo this. We'll see what the diff and we'll do it together. We'll do a diff and diff on the pre-treatment coefficient and we'll see what it equals. But the point is, it's always going to equal this. That right there is going to be observable because in the pre-treatment period, that's going to be a Y0. So that right there will be equal to 0 under no anticipation. And I'll fix it tomorrow. Something's not right, but I'll show you why it's not right. And then, so then this only thing that you get on a pre-treatment diff and diff coefficient, only thing you get is a parallel trend. It's just that, or you can directly measure whether or not parallel trends holds. Okay. In the pre-period. And you can directly measure it because when you run that regression, the only thing it'll be is that it'll be synonymous with it. Okay. So remember that the OLS specification that we discuss, the interpretation, it's interpreted as a a trend, differences in trends. That's all that it is. If it's untreated, yeah, exactly. Only thing that's there is the trend, right? Because there is no treatment effect in the pre-treatment period under no anticipation. There is no treatment effect in the pre-treatment period. There is no treatment effect. So therefore, all there is is the Y zeros. Okay. I actually think that I made that too complicated. Yeah. So, but yes, this will be great. So yeah. So the only thing it can be is the trends. All right. So remember that the OLS specification we discussed collapses the ATT. It's always true. It's an identity. It's just that in the pre-period, you don't have that missing expectation Y0 term, but it just means that the pre-period is basically an opportunity to directly verify parallel pre-trends. And if the past pre-trends are predictive of the future counterfactual trends, then people tend to see that as like a smoking gun. Okay. So the notion is really simple. If parallel trends held in the pre-period, it's reasonable that it still would have, but it's still an assertion. You need to build the case. As we said, at this point, it's a lot easier to show what I'm talking about with a great paper. So we're going to look at a great paper. This paper is really worth studying because this paper really illustrates, I think, this paper really illustrates the ideas that I'm talking about, which is like all the pieces that go together to be very compelling. And it got into the top 5 Quarterly Journal of Economics, top 1, arguably. So it's called Medicaid and Mortality, New Evidence from Linked Survey and Administrative Data by Sarah Miller, Norman Johnson, Lauren Wary, August 2021. For those that don't know, under President Obama, his signature policy was the Affordable Care Act. And it did a lot of things, established markets for insurance and things like that. But it also expanded a poverty program called Medicaid. And Medicaid was a way to get health insurance if you made an income below a certain level. Okay. And not everybody, but the only way they did it, this is kind of my understanding of it. The only way that you would get that generous Medicaid, so it's like maybe Medicaid before required that you made $10,000 a year. Now it might be 20. Okay. Well, the only way you could do it though is that the state had to participate. They had to get like almost like match some of it themselves, and the federal government would like give the rest. And so it was like a matching kind of thing. Well, not every state did it because in the United States, a lot of states were hostile to the Democratic, probably not surprised, hostile to Democratic president, even more so to President Obama. And so only I think like about 13 states rolled out this Medicaid. Now, technically it is a bit of a rollout, but most of them, it's in 1 year. So I'm going to pretend it's a 2x2. But it was a little bit of a rollout. It's not going to matter. So we use large scale. So there's a lot of pieces of this they use, look at this, large scale federal survey data. One thing, very, very valuable data linked to death records, administrative death records. And because they know the names of the people in the survey and in the death records, they know if they're on Medicaid. They want to investigate this is a very similar to John Snow's study. Investigate the relationship between Medicaid enrollment and mortality. Our analysis compares changes in mortality. Now, this is the little piece that we're going to look at. They're only going to focus on the almost elderly people, almost elderly, near elderly. So this study is not going to be about people your age, my age. I like to think that I am near elderly. Yeah, it's the doubly robust diff and diff. We're going to do it tomorrow. So Affordable Care Act, they're only going to look at the effect of the Affordable Care Act on the near elderly adults. This would be people like 60 to 64. You might be wondering, well, why would we do that? Because Medicaid goes for everybody. It's not just the near elderly. You'll see. So we identify adults most likely to benefit using survey information on socioeconomic status, citizenship status, public program participation. We find that prior to the ACA expansions, mortality rates across expansion and non-expansion states trended similarly. But beginning in the first year of the policy, there were significant reductions in mortality in states that opted to expand. Individuals in expansion states experienced a 0.13 percentage point decline, which was a 9, so 0.13 percentage point decline. You have to find what percent of the population are dying, reduce it by 0.132. That'll tell you the average treated on the treated, or that'll tell you how many people that actually was. 9.4% reduction over the sample mean as a result. The effect is driven by a reduction in disease-related deaths that grows over time. All right. So I say that this is like a great paper because they do all 5 of my subjective evidence things. So first, they're going to do something called BITE. They're going to show that the Medicaid expansion actually resulted in people enrolling on Medicaid and becoming insured for the first time. All right. So there's lots of pieces of that. They're going to do placebos or falsifications. They're going to show that there is no effect of the Medicaid rollout on a similar group of people that didn't enroll. Who's going to be similar to the near elderly? The elderly. Why is that? Why are they not on Medicaid? We'll look at that in a second. Then they're going to look at the event study. The whole paper is event studies, actually. It's just event study after event study after event study. And when they lean hard on these dynamic plots. These dynamic plots look amazing most of the time. Their main results is that they're going to show Medicaid expansion caused the near elderly mortality to fall. And then they're going to have a mechanism. They're going to say that they think it's coming from people treating diseases, physicians, Medicaid resulting in the use of health insurance to treat diseases that would have killed them, but because they didn't kill them, kept them alive, causing mortality to fall, compounding over time, kept them alive longer. BITE. BITE is a term that comes from the labor economists. It's often used with the minimum wage. It's a way of saying that the minimum wage actually is binding. You raise the minimum wage. Did you actually put people on the minimum wage? Or was it like you raised the minimum wage and even at that higher minimum wage, wages are still way above that? Okay. So it's like they would say, was the minimum wage, did it bite? Bite has become like a phrase that's sort of like almost equivalent to this like IV phrase of like first stage. It just basically means, did people get on the program when the program rolled out? You have to think really carefully, like what would the evidence be for that? So here, what it meant was US states made Medicaid more generous. People got on Medicaid who would not have been on any insurance otherwise. Okay. It's not the most exciting result, and it is not the point of the paper. But if you can't show BITE, it really weakens the main results, because the only reason the main results make any sense is that when Medicaid rolled out, well, it's not, this would be more like compliance. This would be more like compliance, that in fact, when Medicaid enrollment rolled out, people got on Medicaid. If you had, if non-compliance would be when Medicaid rolled out, nobody got on Medicaid, right? That would be like what we're saying. We're trying to find evidence that we're trying to find evidence for compliance. BITE is like evidence for compliance. So this is like so they're going to show 3 graphs. All right, they're going to show 3 graphs. And these 3 graphs are going to, yeah, I think so. I think that's probably right. I think that's probably right. Yep. It's just that compliance is like, usually, I think that's fair to say, Yinju. I can't see a reason not to say that. Say compliance. Yeah. So we're going to try to look for evidence of bite or compliance. All right. So first of all, they're going to run diff and diffs on Medicaid eligibility. Medicaid eligibility. All right. Now, Medicaid eligibility, these tight confidence intervals like this are basically just saying, you know, there's like that the treatment group and control group, you know, the eligibility category just does not change very much year to year, right? Because it's set, you know. So the number of people that are eligible for Medicaid would be, was there a big change in poor people? Because the eligibility is a threshold. It's a federally set threshold. It doesn't change, but the population could change. So, well, there's never in the United States like a huge change in the number of people that are poor. And when there is, it's small and it's probably part of a general trend. So they show it, and that's why it's really pretty tightly estimated. But then immediately after, what do we get? So we get a large increase of about 45 percentage points, 45 percentage point increase in people that are eligible for Medicaid. All that's saying, it's not that the people are different. It's just saying whatever the income threshold was, it shot up. And as it shot up in the post period, now all of a sudden 45%, you know, there was like a huge number of people that qualified. 45 percentage point increase. I mean, I don't know what the baseline was, what the counterfactual, you know, whatever it was, the sample mean in the pre-treatment was, but it's huge. It's a huge increase in the number of people that are eligible for Medicaid. Not all of them enroll. Okay, so this will be the compliance part, Yinju. This will be the compliance part. This is how many people are on Medicaid coverage. And pre-treatment standard errors are a little bit bigger. Confidence intervals are a little bit bigger because enrollment is a choice. All right. It's not based on a stock of people. It's based on a choice. And in the United States, it's like a fight to get these people to be on public services. It's like a huge deal because they just won't do it. Many people just will not, they'll be eligible. They won't do it for the stigma, certain frictions. There's all these kinds of frictions they think. Anyway, but that kind of stuff isn't really changing over time. It's pretty common for all the groups. So you see here basically zeros. There is no treatment pre-treatment, so it's just measuring differential trends. Okay. And the trends are pretty similar. When it's below the line, means the treatment group is rising or changing at a rate that is a little bit less than the control group. And when it's above it, it's increasing a little bit more, okay, than the control group, but they're pretty close. This will be like percentage points. It's probably like 1 percentage point, and it's not different from zero. So preferably small confidence intervals, point estimates on the line. That's what you're looking for. When you have huge confidence intervals, you can't really rule out anything in there. Then the first year, what do you see? So the very first year, there's about a 7.5 percentage point increase in people on Medicaid. Year after that, about 12. And notice they're different from each other. No, there's not really a rule of thumb. One is too few, and probably 20 is unnecessary. So it's like usually it's I don't think there is one though. I mean, technically, what makes it different than synthetic control, Winchin, is like synthetic control. Synthetic control is different. Synthetic control actually has to have a very large number of pre-treatment periods in order to fit the factor model and to not fit the noise. None of that's going on here. Okay. None of that's going on here. This is just kind of like a heuristic. It's just basically like, like how many do you need to see in order for you to believe the parallel trends? Probably, you want to kind of see it enough over time that you sort of think it probably would have kept going. You go back too far, it'll almost never hold. You go too little, and it's like, you're not really seeing a trend. Then they do this third part. So they know people are getting on Medicaid, but maybe they're just switching from private insurance to Medicaid. Nope. There's a group of people that are getting uninsured that are getting insured that were not uninsured before, because the percent of the population that was uninsured in the Medicaid enrolling states fell 4 to 5 percentage points. 4 to 5 percentage points after. Now they do a falsification, right? So this was their bite results, or what you can just call in compliance. That's their bite results. Here's what we learned. We learned that in the rollout, a bunch of people got on Medicaid, period. That's it. It was near elderly people. We know that this policy rollout put near elderly people on Medicaid that who would otherwise not been insured. Okay. Next, we think, okay, I still don't know if parallel trends is going to hold, though. I'm going to look at an outcome. All right. I'm going to look at the same outcome of my main results, but I'm going to look at a group that is observationally almost identical to my group, except that they did not get on Medicaid. And in the United States, there is a program that starts at age 65 called Medicare, and it is more generous than Medicaid. And if you are 65 or older, everybody's on Medicare and none of them would be on Medicaid. So probably, but whatever it is you think that would have happened to the near elderly group that's unrelated to Medicaid, don't you think it would have happened to the elderly? Like if there was some unobserved shock that happened to the near elderly groups of people in those years, don't you think it would have also happened to the elderly people? So the first thing they show, no effect of the Medicaid rollout on elderly people getting on Medicaid. No change in mortality either. So it's a falsification. They basically say, here, this is an observationally similar group of people who probably are susceptible to the same shocks, the unobserved shocks, and yet nothing happens to them. Then, with all of this, they go to the main result. And the main result is going to be the assertion. All the other stuff is evidence for parallel trends. Here's their pre-trends. Every year after is statistically significant and grows. And this is their main result. This is their main result. And this main result is basically saying that Medicaid expansion under parallel trends and no anticipation and SUTVA. These event study plots are calculating average treated on the treated for each of those years. They then dig into the data a little bit more and they try to figure out why it's happening. And they write, the effect is driven by a reduction in disease-related deaths that grows over time. And that is their paper. And it's the first ever evidence that Medicaid reduced mortality. There was another study done in Oregon. Yeah, exactly. That's right. That's right. It's ruling out the contamination of other factors that might cause people to be on Medicaid. Exactly. Or that might cause, it's ruling out, the falsification is ruling out other things that would have reduced mortality in the post period for the near elderly, even if they hadn't been on Medicaid. Okay. So how do you make this event study? So I have here this do file called simple event study. Let me show it to you. It's in the basic diff and diff section. All right, I'm going to use again. These event studies are not going to look great, but I'm going to show you how to do it two ways. We're going to do the simple 2x2. And we're going to have a treatment group here. All right. Treatment group is you're going to be treated. Sorry. You're going to be treated if you were in that treated in 2006 and year after. Actually, I don't even need that. So here, I'm just going to do this. I'm going to use the treatment group interacted with year dummies. But the way you do it in Stata, if you want to tell Stata, see, watch. If I only do this, it dropped 2000. I want it to drop the baseline because the treatment starts in 06. I have to go IB tell the year dot year. So it dropped. See that right there? It dropped it. So this would be right here. This is like event study coefficients, but you do not want to show a table of event study coefficients. You want to show this kind of thing. So I do it two ways. I'm going to pull out point estimate and both the upper and lower part of the 95% confidence. I'm going to pull it out. Then I'm just going to make it manually myself. Byte does not relate to the parallel trends. Byte relates to the plausibility of the main results by saying that people actually got on the treatment. It's kind of two different things. I guess I wasn't clear about that, but like Byte is basically saying that this rollout actually got people on the treatment. If you can't show that, then it's like you're susceptible to somebody just being skeptical that, I mean, you don't have any evidence that people actually got on the program. Yeah. Okay. So here I made it. I will do that harsher right now. Because it is the baseline. It's the dropped period. You're not able to estimate a point estimate for this. You're not able to get a confidence interval because it's the one everything else was, it's the baseline that everything else is against. So you always have this, you can't get, in a regression, you cannot get all of the coefficients associated with a variable that takes on all values. It's called multicollinearity. But in the diff and diff context, it just means that this is our baseline. It's the dropped unit, which forces it to be the pre-period for all the calculations. Yep, exactly. Exactly. I mean, people want to do it that way. They basically want to, that's what they want to do. It's just they want to say 0 for that. But it's basically just kind of, I mean, it's kind of weird. It's not a 0. It's just like, it's basically just saying it's going to be the relative, the relative thingy. So you can do it long like that, or you can use this program called coefplot, and then it's like really like it's one line. Same thing. So Harsha said, okay, can we go back and interpret the point estimates? Yes. Each of these post-treatment is an ATT if parallel trends holds. Each of these mu terms is only a differential trend. That's all it is. Because like all you have is just Y zeros. Not with diff and diff. Diff and diff estimates an average treated on the treated. To get to the average treatment effect, I mean, we could try to like probably take a diff and diff and do a bunch of weird manipulation, but I actually don't know. I don't know what the assumptions are because that right there, I mean, you would need, in order to get an average treatment effect, you'd have to get the Y1s for everything. Or at least like the Y1s for that, I guess, in the post periods. You have to like somehow impute Y1s here. I don't even know what you would do, to be honest. Because you don't have like, I don't know, you'd be something weird. I don't know what you would do. But it's always the ATT wing. Because you can see like when you go through that simple diff and diff, you know, all that you end up with is that, right? That's the post period for that group. That's what it does. This is why diff and diff only identifies the ATTs, because with under no anticipation, parallel trends, and SUTVA, that's all it can identify. That's all it's left. It's just kind of like, that's what pops out. Probably you get the average treatment effect. It's just not going to be an ATE. This means the state output. Well, for the state output for a given year, this will only be the average treated on the treated. Because what it'll be is it'll be T minus 2. And so instead of being post, it'll be like year 2. So it'll be like, you know, year 2 relative to the baseline. And that'll be year 2, baseline, year 2, baseline. So whatever your event study is going to be, if it's like T plus 4, exactly, right, exactly. It'll be ATT for 06. It'll be like, so this one right here, that's ATT for 06. That's ATT for 07. That's ATT for 08. It's not significant. ATT for 09, ATT for 2010. For the group of units that were treated in 06. And these are, you know, this is not a very convincing event study. Confidence intervals are huge, you know, but that's the idea. Exactly. Yinju, think a falsification is providing the counterfactual in the post period? Yeah. It's like, it's a, well, it's an untreated group, right? It's an untreated group. The treatment should not affect an untreated group, right? Excuse me. Okay. I hesitate. Let's take our 15-minute break now because we're going to do diff and triple diff. We're going to do triple diff right now, and I just want to kind of like do that all at once. So let's take a 15-minute break, and we'll come right back. Triple difference. Triple differences. What is triple differences? Me and Wenchen Wang are talking about this issue about biases in the diff and diff, biased parallel trends. Waldo, that came up earlier. There is no real, you know, probably there is no rule of thumb because it is not technically a test of the parallel post trend assumption. Usually I think what people want to see is like 3 to 5, 3 to 6, something like that. That just kind of shows that for a bit of a stretch, these two groups were observationally identical on their trending Y zeros. That's the idea, right? It's like period after period after period, the changing Y zeros were identical for these two groups, which makes them like observationally equivalent on their trends in Y0. Then it just becomes like one piece of the puzzle that makes a person go, yeah, maybe parallel trends would have held also, but it's not guaranteed, you know, and this is where people confuse the pre-trends with the post-trends. They think that the pre-trends are the post-trends, but see, they're not. This is the, look at what the parallel pre-trend is this. It's always a post period. It's post period changes in Y0 involves a counterfactual. I fixed it. So under no anticipation, there is nothing treated. Under no anticipation, that is a Y0. So every event study coefficient is just going to equal changes in Y0. They're all untreated. So therefore, the only thing it can be is just a differential trend. But, you know, just because these are 0 doesn't mean those are 0. Not without further assumptions, you know, not without more assumptions. Okay. But let us assume that we think that diff and diff is biased. We have reason to believe that diff and diff is biased. And so what we're going to do is we are going to evaluate it. Or sorry, we're going to do something called triple differences. All right. And I'm going to spend the rest of the class on triple differences. Kind of get it right. We're going to look at a simulation I made. We're going to look at some cool pictures. I think you're going to learn a lot from it. So many people, I think, actually have an incorrect understanding of triple diff. They think triple differences is a falsification exercise. It is not. Okay. This is a falsification exercise. Right here. You do a diff and diff on a placebo. On a placebo group. Either on a placebo outcome or a placebo group. All right. That's a falsification. You continue to use your same model, diff and diff, but apply it to a group of people that are not treated, but that are otherwise probably going to be affected by the unobservable. That is not what triple diff is. That is not what triple diff is. Triple diff is not that. It is its own design. Okay. You use it when you have a parallel trends violation. If you do not think you have a parallel trends violation, you just do a falsification, like what Miller, Johnson, Weary did. They did not do triple diff. They just did a diff and diff on a placebo group. That's because they believed their near elderly results satisfied parallel trends. And probably it helped to the fact that the baseline, the pre-treatment trends were parallel. So let's look at this. All right. We're going to be working with biased differences and differences. That's when you use triple differences. You use triple differences when you do not have parallel trends. All right, here we go. Alexander's time to ask a question. He's earned it. Okay. Let's review it and think about it. I mean, what it would be, Alexander, is it will be the same thing as you would do in a diff and diff. It'll be the same thing that you would do in a diff and diff. I'm trying to kind of think through what you even would do in the diff and diff. So like, I mean, everything inside me kind of says probably to fully saturate the model with the covariates. And then you probably should be able at that time to recover the ATT for a particular group. But I need to actually get a little bit of advice on that. So I'm gonna email someone and just ask them, does full saturation all right, well, that pen doesn't work. Hold on. What about this guy? Does full saturation, all right, he doesn't work. Okay. Apparently I have all the crappy ones downstairs. Does full saturation in DID and triple diff, should be regression adjustment, allow you to recover CATTs, conditional average treated on the treated? So it sounds like what you're wanting to know, I think, is can I get a conditional average treatment on the treated? I think. And so regression adjustment does not, regression adjustment allows you. Yeah, we're going to look at that. We're going to look at that. Now it's not parallel trends. It's a little more subtle than that, Saban. It's a different parallel trend. Okay, it's a different parallel trend. It's a parallel bias. I'll show you. I'll show you the quote. Alexander, I'm going to find out, but I think what you're wanting to know is, I can find the ATT, I can find the CATT, which the CATT are these covariate specific ATTs. So find the ATT for men, find the aggregate ATT. Are they different? Something like that. And how do we do that in a different diff context? So I'm going to find out. Because you could just probably interact it, but I bet that's not right. Yeah. All right. I'll find out. I'm going to put this over here. Okay. So let's look at this. Okay, Saban. So here we have a group of states that are going to get some treatment, group of states that aren't. We're going to say the group of states that gets the treatment, New Jersey, group of states that don't, Pennsylvania. And we're going to do our 4 averages and 3 subtractions. So post-treatment, I'm going to get, I'm going to do a first difference on my experimental states. I'll get this. This is an unobservable counterfactual trend. I don't know what it is. Then I get the trend in Pennsylvania. I do the diff and diff, and I don't believe that that's going to cancel out. I have reasons. Right? The ATT is D, but I have reasons to believe that the counterfactual trend in New Jersey is not equal to the trend in Pennsylvania. If I do that, then I cannot use diff and diff, but I might be able to use triple diff. So here's what triple diff is doing. Let's say I had same states, but a different group. Let's say that this was married. Let's say that this was married women, all right? And let's say that this is single men and older women. And we'll say that the married women are going to get treated with a law that allows them to get maternity benefits. Firm will have to pay for their maternity leave if they get pregnant, but not if you're a male and not if you're an older woman. We're going to say older women at this period of time, the technology does not exist, or their birth rates are very low. Okay. So let's calculate it. And let's say that when we do this, this group is not getting treated, but let's say that when we do this, we have the same bias. Triple diff is the difference in 2 biased diff and diffs where they have the same bias. And that's what it meant. That's what it meant, Saban, when it said that it had 1 parallel trend assumption. The parallel trend is the parallel gap, it's the parallel bias. So it's basically like the bias of the true diff and diff is equal to the bias of the placebo. Now, this comes from a 1995 paper by John Gruber. And it actually appeared in the AER, American Economic Review, a few months prior to that Card-and-Kruger minimum wage paper, right? So what he did was a triple diff, and it's actually, in my opinion, not really necessary to do this triple diff, and I'll show you why. So here he has married women. He has married women, and he does a diff and diff. So 1.513 minus 1.547, negative 034. Wages of married women ages 20 to 40 fell in the experimental states, just in the time series, 3.4%, not percentage point, 3.4%, because it's log hourly wages. And then the non-experimental states went from 1.369 to 1.397. They're not being treated, but theirs went up. So when you do negative 034, first difference, minus 028, second difference, you get negative 062. So the diff and diff says wages fell 6.2%. This is the paper where he kind of, quote, invents triple differences. And he basically says, well, I'm going to do it on a group of placebos. I'm going to do it on a group of placebos. Women over 40 and single men 20 to 40. They're not going to get pregnant, even if, well, they're not going to get pregnant. And secondly, they don't have a wife that'll get pregnant. They could be cohabiting, but they won't be covered. And then the older women aren't going to do it. Now, their wages are higher because men make more than women, and older women make more than younger women, right? So we're going to go 1.748 minus 1.759, falls 1.1%. 1.627 minus 1.630, basically a zero. Go negative 011 minus negative 003, that's negative 008. Nothing. Well, this right here, the thing you have to always remember is in a triple difference, whatever that is, it's a measure of the bias. It's a measure of the bias of the true diff and diff. Why? Because what you're going to do next is you're going to take this negative 062. You're going to go negative 062 minus negative 008. That's negative 054. It was off by negative 008, and you corrected it. Well, they're not statistically different from each other. And that's about, that's a pretty small, that's a zero. So his triple diff and his diff and diff aren't really very different from each other. Okay, they're not really very different from each other. So why even do the triple diff? Why not just do a falsification? Why did you have to go this next step? You're only supposed to go to the next step if the first one is biased. And so some people think this is where the world, there's two groups of people out there and their beliefs about the identifying assumption of triple diff. Some people think that the only way that you should be able to believe triple diff is if that's a zero. That's what they think. They think that it should never be that the placebo is driving the triple difference result, which is to say, they think that triple differences is a falsification, because if it's zero, if that's a zero, then the triple diff is just equal to the diff and diff. You never needed to do that in the first place. It was just a falsification. So some people think that way. Gruber's 1995 article, it's not really clear why he needed to do triple diff in the first place. His triple diff is negative 054. His diff and diff, it's negative 062. They're basically statistically identical. The main value of triple diff is you don't use it when you believe parallel trends holds. You use it when you believe it doesn't. So here's an example. Here we have married women in the experimental, non-experimental states, and we have the single men, older women, experimental, non-experimental states. 8 averages, 7 subtractions. Okay? I mean, it had to be, because that's 4 averages. That's 4 averages. That's 3 subtractions. That's 3 subtractions. And there's the 7th. So it's got to be 8 averages and 7 subtractions. So we're going to go before. It's going to be New Jersey kind of effects and married woman effects. And then we're going to have in the after period, we're going to have it go up by a New Jersey trend, and then it's going to go up by a married woman trend. So that when we do the after minus before, and I'm just going to kind of cross stuff out, we do the after minus before, we get rid of that. We're going to do the after minus before for the non-experimental states. That's going to get rid of that. Still got married women. Now we're going to do our placebos. Notice there is no D over here. We're going to do our first difference. We're going to do it for the non-experimental states. We're going to do a first difference. Okay. And so then we get our, no, treatment group was married women. Married women. We have married women is our treatment group. All right, so then we do our second difference. We're going to go, this is our treatment group minus this. Now, we're not going to get rid of everything. Look what we get rid of. We just get rid of the married woman trend because we had a married woman trend control group. So we get D plus NJ minus PA. Remember what we said? We said that right there is the bias. That's the bias. Well, we think that's not equal. And I'll show you why we think it in just a second. Okay. So do it over here too. Okay. We do it with the single men, older women, and it'll get rid of that trend, but it won't get rid of the state trends there. But if when I do the triple diff, right? If that bias is equal to that bias, then the triple difference will equal the ATT. It'll equal the average treatment on the treated. That's the thing to kind of remember. This is what's kind of interesting. What is the interpretation of the triple differences estimator, the coefficient? It's that. What is that? It's post-treatment, experimental states, married women, which is the average treatment on the treated. You go through all of this stuff, you're still just getting average treatment on the treated. Average treatment on the treated. This is the regression equation, kind of getting Alexander to what you were asking about what would be the specification for exploring the heterogeneous treatment effects with respect to the covariates. Everything inside me is saying that I'm going to have to fully saturate it with that and then regroup, probably by aggregating over something, probably this. You have to sum over it or something. I don't know. I'm not positive. I have a hunch, but Harsha, it needs to be a group that has the same trend, okay, as married women. Oh yeah, over here. It needs to be a group that is gonna have the same counterfactual trend right there. And it's gonna have the same trend right there. So again, it's like trying to pick somebody that's comparable. It's gonna be somebody that's comparable. It does not. It does not. It does not. It does not need that, Reese. It only needs whatever that is, it's the same as that. So this could be like, 10, this could be 20. This could be 20 and that could be 10. So then the difference is a 10, and this could be 100, and this could be 90, and the difference is a 10. You just need the gap. You need the bias to be the same. You need the bias to be the same. I think I just said something wrong. So you need the bias to be the same. You need the bias to be the same. That's it. Preferably though, finding groups that are going to be on similar trends is probably the way to do it, but you just need the same trend. Standard errors, Reese, probably better to get it from a regression. You're going to get it from a regression here. I don't exactly remember how Gruber did it in his paper. He's probably doing some You know, I'm not sure how he did it. It's probably some parametric method or something, but you know, you could always bootstrap, you know, or something like that. But the regression will get it for you. Here's what you have to do though. That's your post dummy. This is the 2x2. All right. That's your post dummy. High wage worker. This should be the, I need to fix that. Hold on. This is the DE. Where'd that? Man, I'm losing all my, I only have one functioning pen. Let's see. Change AR high wage worker to experimental women. Okay. That's the DDD and regression. So basically, what you need is a group dummy. Group dummy. The group here is married women or single men. Okay, so we say married women. That's a married women dummy. It's post dummy. So that's your after dummy. This is all for the 2x2. And that is your treatment group dummy. That is experimental states. Right? You could flip them. You could have one be the group and one be the treatment state. It's not really going to matter because they're all going to be interacted in the end, and that's going to be your coefficient. But point is, though, you're going to have to fully saturate this model with respect to, I mean, it's not so different. Think back to the diff and diff. Think back to the diff and diff regression. Oh my gosh. Right? Dummy, dummy, interact. It's a saturated OLS model in the dummies. This is the same thing. 3 dummies, group, post, state, interact them in every combination. Interact that, interact that, interact that. There's your triple diff. That beta 8 is the ATT. I need to get rid of this. This is not right. Well, this is true. This is true. If the placebo diff and diff is not 0, you might have difficulty convincing the reviewer that the triple diff removed all the bias. But I need to take that out. I need to take that out. This is true that you will run into. So yes, if you write up a triple diff and you are writing it up under the assumption that you have a biased diff and diff, this is the biased diff and diff right here, and that you have another group that has the same bias, you're going to have to really educate them because most people have not read this paper that I think it was that Saban posted. Saban posted this paper. Came out in 2021. I think I want to say though, I just want to double check. I think in the mixtape, I did work this out, but probably not. Yeah. See, so I did too. While different has introduced new ones, this is the final source of selection bias. So the solution is not without its own set of unique parallel trends, but one of the parallel I like to see is this L minus H term. Parallel trends assumption that the effect can be isolated, the gap between the high and low wage. So I struggled exactly to kind of articulate it, but I did technically articulate it before this paper in 2021 because but my paper was being circulated. My book was being circulated as far back as 2018. So I think I get credit for doing it first, but I didn't work it out with all the potential outcomes. So he has it with all the potential outcomes. And he basically says, we give a couple of presentations of it and show that even though the estimator can be computed as the difference between 2 different diffs, it does not require 2 parallel trends assumptions. The reason is that the difference between 2 biased diff and diff estimators will be unbiased as long as the bias is the same in both estimators. Therefore, it requires only 1 parallel trend assumption to hold. and it's this one. That is the parallel trend. Trend is the trend in the, I mean, it's a trend here. It's like a trend and a trend and a trend and a trend, but it's like the bias is the trend. It's a, crazy enough, this is itself a triple diff just on all the Y zeros. All right, so let's look at a lab that I made. I actually made this. It's inside here. I got obsessed with this. I wrote like four Substacks about it. And yeah, Yin June, here you go. You know what you're gonna have to do? An event study. You're gonna have to make an event study. I recommend what I'm about to show you I recommend you draw this picture. Okay. I recommend that you draw this picture. So in this, I have a simulation that's going to illustrate for us. It's called DDD2. The ATT is going to be negative 5,000 and the diff and diff is going to be biased. The bias, what you're going to find with diff and diff is negative 7487. So it's biased by 2487. The non-parallel trends bias is negative 2487. I'm going to replicate Gruber with simulated data where the placebo diff and diff is going to be close, negative 2507. I'm going to present a triple diff, which is around negative 4972. Let's look at it. All right, so here it is. This is triple diff. I'm going to use a biased diff and diff and an unbiased triple diff. All right, so we're going to have a seed here. I'm going to have 40 states. First 20 states are the experimental states, which means that's like these, there's going to be 20 of these, and be 20 of these. Okay. I'm then going to put 50 cities in every state. Okay. So I can get averages. And then in every city, I'm going to have 3 kinds of workers: married women, older women, men. Okay. Then I'm going to make 10 years of data. So when I do this, I have 60,000 observations. And then I'm going to find the time period. 2015 is the post. Okay. And now I'm going to have baselines, but I'm going to kind of mess around with these baselines. Not everybody's going to have the same baseline. So the married women, the older men, married men make the most, older women make the second most, married women make the least. For the experimental states, they're going to have a larger baseline. So the baseline here is going to be 60,000 for married women in the experimental states, but in the non-experimental states, it's going to be 40,000. All right. Then I got this counter. I encourage you to play around with this, sort of see. All right. Now I'm going to make my trend. If I'm in the experimental states, I'm going to have a trend of 1,000 per period, but if I'm in an experimental state, it's going to be 1,500. I'm also going to have a group trend. You'll see how this is working in a second. If you are, that might not be right. It's not going to matter, but that might not be. Well, anyway, worker 2, the older women, I think I should have done it. Older women, and I think it should I'll mess around with it later. So state trend baseline here. Okay. Men and women, the different groups are going to have different trends. Here's how the trends are getting used. Y0 baseline state trend times year diff. So year diff is just my counter. Okay. How many years has it been since 2010? So I'm going to have a state trend and a group trend. I'm going to make an error term. This error term is what's making it so that it's not like exact. I've got like a pretty big variance, $1,500. So that's why it doesn't get it exactly right relative to the sample size. So Y0 is just going to be Y0 plus the error. And then my treatment effect is going to be Y1. I'm going to have Y1 is going to equal Y0 unless it is the experimental states Oh, that's what I messed up on. Oh, I see what I did wrong. All right. Well, yeah, that's what I did wrong. So I have here worker two. Worker two is the married women. That was what I messed up on. So worker two, right? If you are in the experimental states, and you are worker two, which is now been changed to married women, and it is the after period, then that is going to be your treatment effect. It's going to be Y1 minus Y0. Here's Y0, where Y0 is baseline. That's baseline. This is like baseline here. Plus a state trend times the year difference, plus a group trend times the year difference. So that's giving me this and that. Okay. And then I'm going to get treatment effects are under no anticipation. They're 0, but I'm going to replace Y1 with Y0 minus 5,000 if you're in the experimental states, married women after period. Okay. So that's here. We can see ATT. The ATT is negative 5,000. Okay. Some delta there and some, some delta if experimental equals 0. Some delta if experimental equals 0. Should be 0, right? I just did that, because that's the only group that's getting treated. So it's easier to do it that way. So here we go. Treatment indicator. Got to have a treatment indicator because we're going to run regressions in a minute. So treatment indicator equals 1 if it's the post-treatment worker after. Because that's going to be how we move between Y1 and Y0, which is the switching equation. So I am modeling this from the ground up using potential outcomes. Okay. Now I'm going to calculate 8 averages, 7 subtractions. 1, 2, 3, 4, 5, 6, 7 subtractions. Bias diff and diff case 1 using the 8 averages. And first I'm going to do diff and diff. First I'm going to do the diff and diff. So what I'm going to do here is I'm going to get to this one. Sorry, this one. Average, 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 average. 3 differences. So I'm going to get average, local this, display it. All right, so we know the treatment's negative 5,000. Diff and diff's giving me negative 7487. Yes, you can. You can, Becky. It's better pedagogically, in my opinion, to just kind of always do these things as simple 2 by 2 so that we don't always end up in a regression model. I always want to go from the core thing to the regression model and then just kind of go back and forth so that you kind of can see that the regression model is just doing these. The regression model is this table, right? That's all I'm trying to do. Well, here we get negative 7487. Now I'm going to do the regression. I'm going to have a treated, if you're experimental worker, same bias here, negative 7487,241, negative 7482,422. I do not know why it's not exactly the same. It's some rounding thing, or I don't really know. It's got something to probably do with like floats versus something. These things I don't really understand. But here we're going to do an event study. And notice the event study is biased. Okay, so Yinju, look, a biased event study. You see the biased event study, you go, I can't do it unless I can find somebody with a similar bias. So now I'm going to look at the biased single men, older women. All right, so look, 4 averages, 3 subtractions. There is no treatment effect. So the only thing I'm going to get is the difference in the New Jersey trend and the Pennsylvania trend. Ah. All right. Similar. Mine's negative. Like mine, that's off by a little bit. It's off by a little bit. So now what we're going to do is we're going to do a diff and diff on the placebo. Now, this one does not look exactly like the other one. And let me show you why. This one looks a lot steeper, right? 2,000 to negative 3,000. But let's go back up here again. $2,000, $8,000. See, because this one includes the treatment effect, it scales is much larger. And so seeing this up here, you know, it doesn't look the same. Like, I wonder if I can, how do you, I don't really know how to make it. It sometimes just does it. So if we do this though, with our placebo, watch how much steeper, see, so much steeper, but that's because the scale is so much shorter, right? But notice here, you just got that trend. All right, so now let's do the unbiased triple differences. I do the, I'm going to do all of my averages. That might not do it. Hold on. After married, yeah, I gotta go all the way from the top. Oh, dang it. And bias 1, bias 2. There it is, negative 49.79 on the triple diff. Here's the triple diff regression right here. Oh. There's the triple diff regression up here. Negative 49.79. 0.42. Negative 49.79.42. See, it does all these things. You don't give a crap about any of these others unless you care about average earnings. You could use these coefficients in various ways to get average earnings. You know, you get the constant average earnings for, you know, the control group in the pre-period. I think that would be the non-experimental states, married women. I'm not positive. So, but there it is. Now we're going to do the event study. Oh, gosh. I have literally never in my entire life seen anybody go this far with a triple diff. I have never seen a single triple diff event study, ever. It's got to be there, though. Because why? Because you've got to provide evidence for the parallel trend, right? There it is right there. There's the negative 5,000. So look what I did. I think what you do is you plot all of them on top of each other. There's your, you need to show that, see, these are our biased diff and diffs. If you're going to convince somebody of a triple diff, you need to show them the biased, you need to show them the bias in the event study of both diff and diffs so that they can see that this number minus this number equals that, right? Because you can, and they'll see it. It's like just, they'll see it. And then show them over here the post-treatment, right? Because this number, it'd be this one. This number minus that number is this. This number minus that number is this, and so forth. Okay. And that's where we're getting this. And so, you know, you've got, I know, I love it too. Thank you, Yinju. I love it. It's so rare. I feel like I have something valuable. So I think this is the way to do it. I think this is the way to do it. This is what you want to show them. And what's nice is at the moment we have it all in Stata, okay? And we'll get it in R. We'll get it coded up in R. I'm working with Kyle to get it coded up in R. But this is gonna be this is like I think a really valuable pedagogical exercise. Okay. Yeah. So to answer Winchen's question, he says, or they say, do we only use triple difference when we have clear glass? Yes. Yes, you do. Because it is literally, this is the only evidence you have that the only evidence you really have that these two biases are the same, only evidence you have that these two biases are the same is the pre-trends. It's the same reasoning. It's the same reasoning that we've used before. Now, here's the deal, though. Here's the thing. Some people think that triple diff was only valid if that's a 0. What does it mean when they think that? A lot of people think that triple diff requires 2 parallel trends. That one and that one. And it is not true. Main value of triple differences is you use it when it is not. When it doesn't hold. Okay? When it doesn't hold. So you use it for this situation. It's its own design. It's its own design. It's not a falsification. Okay? It's not a falsification. If you believe that you have parallel trends, you don't do triple diff. You don't need to. You just do parallel trends and you just do diff and diff, and then you do a falsification on your placebo, which is what he did here. Just do that. Just do a falsification. If you believe that that's parallel trends holds, just do that. But if you believe that parallel trends doesn't hold, then that's not, that 0 is not going to help you. Okay? You need something that's got the same bias. People that do triple diff just never really will do. And I think it's partly the reason that you've not seen this is because triple difference is not as popular. It's not as popular as diff and diff. I've not done the Google Scholar search. I don't think it's as common. I have one. My first publication was my 3rd chapter was a triple diff, but it's not as common at all. It's not as common. So I think since it's not as common, it doesn't get the full weight of all the practices. So it used to be people thought triple diff required 2 parallel trends. It does not. It is a real design. 1 parallel trend assumption. It's a weirder parallel trend, though. It's a parallel bias. The bias of the true diff and diff is the same as the bias of the placebo. The ladder of evidence still holds. You want to present the event study plot. My code provides it for you because you need to evaluate that parallel bias assumption. Given the lack of triple diff literacy, here's what I was going to tell you though. Given the lack of triple diff literacy out there that you are going to run up against, you're going to run up against people that believe you need 2 parallel trends. So what does that mean? What do you do when you know your reader is wrong? You educate them. But you can't be condescending because, so you got to, it's my opinion, somehow, probably if you write a triple diff paper, you're going to have to really show, you're probably going to want to get the actual potential outcomes out of this. I didn't put the potential outcomes in here because it's so big. It's basically 10, 10 conditional expectations because it's going to be like ATT plus 8 potential outcomes in a diff and diff format. So it's going to be hard to, I find it hard to present it compared to just doing this. So you're going to need to educate them. You're going to have to say you're going to have to say words like, a lot of people think that triple diff requires 2 parallel trends, but Olden and Moen, well as Cunningham, 2021, show that that is not true. That in fact, it has 1 parallel trend assumption. It is the parallel bias term. And then I would walk them through it, to be honest, or put it in the appendix. But then I would say, to provide evidence for it, that this group actually does have, is a viable candidate, I'm going to do an event study. And I bet you, this is my hunch, I bet there are not very many triple diffs. I bet you there are not very many triple diffs where you find this is the bad news of it. I don't know, but I bet finding parallel bias is not as easy to do as you think. That's my guess. That's my guess, is that lots of times where triple diff is holding up, it's probably these situations where that really is a 0. But if that is a 0, just do a diff and diff. Ladder of evidence still holds though. If you do get it, if you do not get parallel trends in the pre-trends, search. Don't give up. Search. See if you can find another group that you think has comparable bias. A similar group on a similar group of trends. Keep looking. Don't give up. And you're going to want to then show that event study plot. Now, probably what you're not going to be able to do is do like the falsification. That's my guess, is it's going to be hard because you're like already using the falsification, within it. So given the lack of triple diff literacy, you may have to write this anticipating a reader and the editor who are confused. And that's a skill. That's a skill to educate them, to bring them along. But overlaying all 3 plots could help. So in conclusion, we have a little bit more, but we're not going to do it. We'll start on this tomorrow. Remember, homework. All right, homework. Homework 1, here, page 58. Write out what this diff and diff identifies if you're using an already treated group. All right. Number 2, write out what diff and diff identifies if you lose no anticipation. That's our homework. Okay. And then secondly, I think it would be fun if you would kind of play around with some of these labs we did. Play around with them. Go through simple event study. Go through equivalence. Okay. Go through the triple diff. If anybody wants to try to take a step, it's the DDD2. Oh, look at that. Well, that might work. Res source. No way. Did he really already make this? Kyle probably made this already. Let's see. This whole time I didn't think he did. So yeah, it's gonna be beautiful, and it's like gonna, be like so pretty. So I don't remember doing it. Oh yeah, I definitely didn't do this. Oh, let's look and see what it does. Oh yeah, look at that. Nope. Well, why don't one of y'all try to fix it? One of you people that are good at this, try to fix it. So, but I would play around with it, do the homework, play around with it. we're in a good position. Tomorrow we're going to do covariates. And I think we're in a really good position to make a big dent in that material, but review this. And I really want you to, and if you want to read that Laura Wary, Johnson and Miller paper, I think it's just like a great paper for just kind of thinking in a framework way about evidence versus results. Okay. All right. Give me a couple of hours and I'll get this posted. Great, guys. See you tomorrow, bright and early.